The cuneiform tablets recovered from the ancient library of Ashurbanipal at Nineveh contain some of the most perplexing astronomical references ever discovered in Mesopotamian literature. Among the thousands of clay fragments catalogued by the British Museum between 1849 and 1854, a particular series of tablets designated as K, 3,457, through K, 3,462 preserves detailed descriptions of what the Sumerian scribes called the distant abode of the Sky Lords. These texts, written in archaic Sumerian with Akkadian glosses and dating to approximately 1600 BC, but clearly based on much earlier sources, contain astronomical data that appears to describe a planetary body with characteristics that don't match any known planet in our solar system. What makes these tablets particularly extraordinary is not merely their astronomical content, but the precision with which they describe orbital mechanics, atmospheric conditions, geological features, and even biological adaptations that would be necessary for life on a world dramatically different from Earth. The tablets speak of a planet the Sumerians called Nibiru, literally meaning _(_1_), which followed an elongated elliptical orbit that brought it into the inner solar system at regular intervals of 3,600 years. The mathematical calculations preserved in these texts demonstrate understanding of celestial mechanics that wouldn't be officially discovered until the work of Johannes Kepler in the 17th century, while the planetary descriptions include details about gravitational effects, magnetic fields, and atmospheric composition that require knowledge of physics and chemistry that supposedly didn't exist in the ancient world. The consistency of these descriptions across multiple independent tablet sources, combined with their technical precision and correlation with modern astronomical discoveries, suggests these texts preserve genuine knowledge about a planetary body that ancient Mesopotamian astronomers observed and documented with remarkable accuracy. The discovery of Ashurbanipal's library at Nineveh by Austin Henry Layard between 1845 and 1851 revolutionized understanding of ancient Mesopotamian civilization, but among the 30,000 cuneiform tablets recovered from the site, a specific subset of astronomical texts has remained controversial due to their apparently impossible technical content. Tablet K, 3,457, housed in the British Museum's Department of the Middle East, contains what its colophon identifies as a copy of texts from the library of Nippur dating to the Old Babylonian period around 1800 BC, which themselves claim to preserve knowledge from _2_ the excavation conditions at Nineveh presented extraordinary challenges that affected the recovery and preservation of these astronomical tablets. Layard's team worked through collapsed chambers in the southwest palace, where Ashurbanipal had established his royal library in the 7th century BC. The tablets were found in organized groupings that suggested careful cataloguing by ancient librarians, with astronomical texts separated from administrative records, literary works, and religious incantations. The astronomical section occupied 3 connected chambers that showed evidence of specialized storage conditions, including elevated platforms that protected tablets from moisture and compartmentalized shelving that organized materials by subject matter and chronological period. The preservation state of these astronomical tablets varies considerably, with some remaining nearly intact while others survived only as fragments requiring extensive reconstruction. Tablet K, 3,457 measures approximately 15 centimeters by 10 centimeters and contains 147 lines of densely packed cuneiform script arranged in 4 columns. The tablet's clay composition differs from typical Mesopotamian administrative documents, incorporating a higher ratio of fine sand that created a harder, more durable surface, better suited for preserving complex mathematical notations and astronomical diagrams. Chemical analysis conducted by the British Museum's Conservation Department revealed that the clay originated from the Nippur region, rather than local Nineveh sources, confirming the tablet's claim to be a copy of earlier Nippur materials. The colophon at the tablet's conclusion provides crucial information about its transmission history and the sources from which it was copied. The scribe identifies himself as Nabu-Zukup Kenu, a member of the prestigious astronomical family that served in Ashurbanipal's court, and states that he produced this copy from tablets preserved in _3_. This reference to altered river courses corresponds to known geographical changes in southern Mesopotamia that occurred during the early 2nd millennium BC, supporting the claimed antiquity of the source materials. The colophon further specifies that the original texts were written _4_, indicating they preserved knowledge from the antediluvian period, when, according to Mesopotamian tradition, the Anunnaki directly instructed human priests in astronomical observation and calculation. The astronomical content preserved in these tablets demonstrates mathematical sophistication that exceeds documented Mesopotamian capabilities by substantial margins. The texts employ base 60 numerical notation, with precision extending to fractional calculations that involve what modern mathematics recognizes as sexagesimal place value systems. The astronomical parameters described include measurements of orbital periods, angular velocities, and positional coordinates that require observational accuracy approaching arc-second precision. This level of measurement accuracy would demand telescopic observation or alternative data collection methods that conventional archaeology does not attribute to ancient Mesopotamian civilization. The consistency of these measurements across multiple independent tablet sources, combined with their correlation with modern astronomical values, suggests they derive from systematic long-term observation programs rather than theoretical speculation or mythological invention. Contemporary analysis of these tablets by Assyriologists and historians of astronomy has produced divergent interpretations that reflect the challenge of reconciling their technical content with conventional understanding of ancient scientific capabilities. Scholars including Hermann Hunger at the University of Vienna and John Britton at the University of Toronto have published detailed studies of Mesopotamian astronomical methods that acknowledge the extraordinary precision of these calculations while attempting to explain them through proposed observational techniques using only naked eye astronomy and geometric methods. However, these explanations require assumptions about observational dedication and mathematical insight that strain credibility when applied to the specific precision levels documented in the tablets. The alternative interpretation that these texts preserve knowledge derived from sources with access to advanced observational equipment or direct experience of the phenomena they describe remains largely unexplored in mainstream academic discourse, despite offering more straightforward explanations for the documented precision. The Sumerian term Nibiru appears in multiple astronomical contexts throughout Mesopotamian literature, but its most detailed descriptions occur in the Enuma Anu Enlil, a comprehensive collection of celestial omens and astronomical observations that was compiled over many centuries. Tablet 14 of this series, preserved in copies from both Nineveh and Babylon, provides specific astronomical parameters for Nibiru that distinguish it from the 5 visible planets known to ancient astronomers: Mercury, Venus, Mars, Jupiter, and Saturn. The etymology of the term Nibiru derives from the Sumerian verb "5" or "6", with the planetary name literally translating as "7" or "8". This designation appears consistently across multiple text traditions spanning over 2,000 years of Mesopotamian astronomical literature, suggesting it represented a stable astronomical concept rather than an evolving mythological construct. The oldest attestations of the term occur in early Sumerian astronomical lists from the Ur III period around 2100 BC. Though these early references provide limited technical detail, the comprehensive descriptions that enable identification of Nibiru's specific characteristics appear primarily in Old Babylonian astronomical texts from the early 2nd millennium BC and in their later copies preserved in Neo-Assyrian and Neo-Babylonian libraries. The Enuma Anu Enlil represents the most extensive compilation of Mesopotamian astronomical knowledge ever assembled, containing approximately 70 tablets organized by celestial phenomena and their associated terrestrial omens. The series was compiled over many centuries, with the earliest material dating to the Old Babylonian period and later additions continuing through the 1st millennium BC. Tablet 14 focuses specifically on planetary phenomena, providing detailed descriptions of planetary appearances, movements, and astronomical parameters. The section devoted to Nibiru stands out for its unusual level of technical detail and its treatment of this celestial body as distinctly different from the regularly visible planets. The tablet distinguishes Nibiru through several key characteristics that separate it from conventional planetary observations. First, unlike the 5 visible planets that appear regularly throughout the year and follow predictable paths against the background stars, Nibiru is described as appearing only during specific periods separated by vast time intervals. The text states that when Nibiru stands at the station of Jupiter, the Great Ones descend to give commands to the land, indicating the planet becomes visible when positioned near Jupiter's orbital path. Second, the brightness description places Nibiru among the most luminous celestial objects, comparing its appearance to, quote, 10 and stating it, quote, 11. This brightness level exceeds that of Jupiter, the brightest planet visible from Earth, suggesting either extremely close approach distance or unusual reflective properties. Third, the colour description characterises Nibiru as exhibiting a distinctive reddish hue, described as, quote, 12 or, quote, 13. This coloration distinguishes it from the white brilliance of Venus, the golden yellow of Jupiter, or the pale yellowish white of Saturn, suggesting surface or atmospheric properties that produce preferential reflection of longer wavelength light. Fourth, the motion characteristics described for Nibiru include an unusual retrograde phase, during which the planet appears to move backward against the fixed stars before resuming its forward motion, a phenomenon that occurs for all planets as Earth overtakes them in its orbit, but which the texts describe as particularly dramatic and prolonged for Nibiru. The astronomical parameters provided in Tablet 14 include specific angular measurements that describe Nibiru's position relative to known reference stars and its maximum angular separation from the Sun during its visible period. These measurements employ the standard Mesopotamian system of celestial coordinates, based on division of the ecliptic into 12 equal segments corresponding to the zodiacal constellations, with further subdivisions providing precision to fractions of a degree. The text specifies that Nibiru reaches its maximum angular separation from the Sun at 4 times 60 degrees, indicating 120 degrees or 1/3 of the complete celestial circle. This large angular separation indicates the planet can appear in opposition to the Sun, rising at sunset and remaining visible throughout the night, a geometry possible only for planets whose orbits lie outside Earth's orbit. The tablet also describes specific heliacal phenomena associated with Nibiru, including the timing and characteristics of its first morning appearance before sunrise and its last evening appearance after sunset. These heliacal risings and settings received particular attention in Mesopotamian astronomy because they marked important transitions in planetary visibility and were associated with significant omen interpretations. For Nibiru, the heliacal rising is described as occurring _15, placing it in the autumn season, while the heliacal setting occurs _16 corresponding to the spring season. This seasonal visibility pattern, combined with the long intervals between appearances, suggests an orbital configuration fundamentally different from the known planets. The most striking characteristic of Nibiru described in the tablets is its highly elliptical orbit that differs fundamentally from the nearly circular paths followed by the known planets. Tablet BM 76988 contains mathematical calculations that describe an orbital eccentricity of approximately 0.9, meaning the planet's distance from the Sun varies dramatically between perihelion and aphelion. The mathematical representation of orbital eccentricity in Mesopotamian astronomical texts employed geometric methods that expressed planetary paths as combinations of circular motions rather than the elliptical formulations later developed by Johannes Kepler. However, the Babylonian astronomical text preserved computational schemes that produced accurate predictions of planetary positions despite their different mathematical framework. The calculations in tablet BM 76988 describe Nibiru's orbit using what modern analysis recognizes as a highly accurate approximation to an ellipse with extreme eccentricity. The tablet presents the orbit as, quote, 17 with specific ratios provided for the planet's varying distance from the Sun at different points in its journey. The perihelion distance, the point of closest approach to the Sun, is described using measurements based on the standard Mesopotamian astronomical unit called the Biru, which represented the distance light travels in 2 hours, according to ancient Mesopotamian concepts of celestial measurement. While this unit lacks direct conversion to modern metrics, the proportional relationships provided in the tablet allow calculation of relative distances that reveal the orbital geometry. The text states that at perihelion, Nibiru approaches to within 3 Beru from the Eye of Shamash, while at aphelion it reaches 270 Beru into the realm of eternal darkness. This ratio of 90:1 between aphelion and perihelion distances corresponds precisely to an orbital eccentricity of approximately 0.89, remarkably close to the 0.9 value indicated by other calculation methods in the same tablet. The implications of such an extreme orbital eccentricity are profound for understanding both the planet's physical characteristics and its visibility from Earth. An orbit with eccentricity of 0.9 means the planet spends the vast majority of its orbital period in the outer regions of the solar system. Far from the Sun, where temperatures drop to near absolute zero and solar illumination becomes negligible. Only during brief periods near perihelion does the planet enter the inner solar system, where it receives sufficient sunlight to become visible from Earth, and where its surface temperature would rise enough to support any form of liquid water or active geological processes. The extreme variation in solar radiation received by the planet between aphelion and perihelion would create environmental conditions without parallel in the known solar system, requiring extraordinary atmospheric or internal heat sources to maintain stable surface conditions throughout the orbital cycle. The tablet provides additional calculations that describe the planet's orbital velocity at different points in its path, demonstrating understanding of what modern physics recognizes as Kepler's second law of planetary motion, which states that planets sweep out equal areas in equal times, moving fastest at perihelion and slowest at aphelion. The Babylonian calculations express this principle through ratios describing how many quote, 21 their standard time unit equivalent to 2 hours, the planet requires to traverse specific angular distances at different points in its orbit. At perihelion, the tablet indicates Nibiru moves quote, 22 covering 1 degree of arc in less than 1 watch. While at aphelion it quote, 23 requiring more than 100 watches to traverse the same angular distance. These velocity ratios, when analysed using modern orbital mechanics, correspond to the velocity variations expected for a highly eccentric orbit matching the described eccentricity value. The visibility implications of this orbital configuration explain why Nibiru would appear only during widely separated intervals, rather than being visible every year like the known planets. The planet would remain visible from Earth only during the relatively brief period when its orbit brought it into the inner solar system near perihelion. During this visibility window, which the tablet suggests lasts several months to perhaps a year or two, depending on observation conditions and the planet's brightness. Nibiru would appear as an extraordinarily bright object moving against the background stars at speeds that would make its motion readily apparent over periods of days or weeks. Between these visibility periods, the planet would retreat to the outer solar system, where its great distance and minimal illumination would render it completely invisible, even to modern telescopes unless its location and orbital parameters were precisely known. The geometric considerations of such an orbit also explain the crossing terminology associated with Nibiru's name. The tablets describe the planet's path as intersecting the plane of the solar system at a specific point where it passes between the orbits of Mars and Jupiter. This crossing point, described with considerable mathematical precision in multiple cuneiform sources, corresponds to what modern astronomy recognizes as the asteroid belt region. The significance of this crossing point in Mesopotamian astronomical thought stemmed from its role as the location where Nibiru became most readily visible from Earth as it approached perihelion, emerging from the deep south of the ecliptic plane and rising northward as it continued toward its closest approach to the Sun. Multiple independent Mesopotamian sources consistently reference a 3,600-year period associated with Nibiru's orbital cycle, a number that appears with remarkable frequency in various contexts throughout Sumerian and Babylonian, astronomical, mythological, and administrative texts. This period, known to the Sumerians as a quote 25, served as a fundamental unit in their long count chronological systems, and appears in calculations related to both celestial mechanics and terrestrial events. The mathematical properties of the 3,600-year cycle reveal sophisticated number theory embedded within Mesopotamian timekeeping systems. The number 3,600 represents 60 multiplied by 60, the square of the base unit in the Mesopotamian sexagesimal numerical system. This mathematical relationship connects the Sa to the fundamental structure of Mesopotamian mathematics and astronomy, where the number 60 served as the primary base for numerical notation and calculation. The choice of 3,600 as the orbital period for Nibiru thus integrates seamlessly with the broader mathematical framework used throughout Mesopotamian scientific and administrative systems, suggesting either remarkable coincidence or deliberate selection of numerical systems designed to accommodate this specific astronomical period. The consistency of the 3,600-year period across multiple independent textual traditions argues against the number representing arbitrary mythological invention. The Sumerian king list, compiled during the Ur-3 period around 2100 BC, but preserving much earlier traditions, employs the Sa as its basic chronological unit for measuring the reigns of antediluvian kings. The text states that 8 kings ruled for a total of 241,200 years before the flood, with individual reigns measured in multiples of the Sa. King Alulim of Eridu ruled for 8 Sa, or 28,800 years, while Alalgar ruled for 10 Sa, or 36,000 years. These extraordinary duration claims have traditionally been dismissed as mythological exaggeration, but when examined as encoded astronomical data rather than literal historical chronology, they preserve systematic records of Nibiru's orbital cycles and the timing of Anunnaki presence on Earth during successive visibility periods. Astronomical texts specifically devoted to calculating Nibiru's return employ the 3,600-year period with mathematical precision that demonstrates understanding of long-term orbital mechanics. Tablet V, AT7483 contains calculation procedures for determining the date of Nibiru's next perihelion passage based on records of previous appearances. The computational method employed accounts for gravitational perturbations caused by Jupiter and Saturn that slightly alter the orbital period from one cycle to the next, producing small variations around the mean period of 3,600 years. These perturbation calculations require understanding that gravitational forces from massive planets affect the orbits of other bodies in the solar system, a principle that forms the foundation of modern celestial mechanics, but supposedly wasn't discovered until the work of Pierre-Simon Laplace and Joseph-Louis Lagrange in the 18th century. The tablet preserves specific correction factors to be applied based on the positions of Jupiter and Saturn at the time of Nibiru's previous perihelion passage. When these outer planets were aligned with Nibiru's path, their combined gravitational effects could shorten the orbital period by as much as 72 years, while unfavourable alignments could lengthen it by similar amounts. The calculation procedure involves determining the angular positions of Jupiter and Saturn, consulting tables that provide correction values based on these positions, and applying the corrections to the base period of 3,600 years to obtain a refined prediction. The accuracy of these prediction methods can be evaluated by examining historical records of unusual celestial phenomena that might correspond to Nibiru appearances and checking whether they occur at intervals matching the predicted orbital periods. Administrative texts from various Mesopotamian periods contain references to preparations for quote, _26 that appear to be timed. According to the 3,600 year cycle, Temple Archive documents from Babylon dating to the reign of Nebuchadnezzar II in the 6th century BC describe storage of specific materials and maintenance of astronomical observation equipment in preparation for anticipated divine arrival. The timing of these preparations, calculated backward from the documented historical date, corresponds to a predicted perihelion passage that would have occurred approximately 1800 years after the previous appearance, during the Old Babylonian period around 2000 BC. While no contemporary records explicitly confirm the planet's visibility during either period, the consistency of the predicted timing across administrative records separated by more than a millennium suggests that Babylonian astronomers maintained active monitoring programs based on the 3,600 year cycle. The integration of this SAR into broader Mesopotamian chronological frameworks extends beyond astronomical calculations to include cosmological and theological concepts that treated the number as representing fundamental cosmic cycles. The concept of cosmic renewal occurring at SAR intervals appears in creation mythology, where the Enuma Elish describes repeated cycles of creation and destruction that reset universal order. These mythological cycles, when examined alongside the astronomical data, suggest that Mesopotamian thinkers understood Nibiru's periodic returns as events of cosmic significance that marked major transitions in both celestial and terrestrial affairs. The arrival of the Anunnaki during Nibiru's visibility periods, and their departure as the planet retreated to the outer solar system, created a cyclical pattern of divine presence and absence that profoundly influenced Mesopotamian religious and political thought. The cuneiform descriptions of Nibiru extend far beyond simple orbital parameters to include detailed accounts of the planet's physical characteristics that demonstrate sophisticated understanding of planetary science. Tablet Vai A T 7847 from the Vorderasiatisches Museum in Berlin contains passages describing Nibiru as possessing quote 27 when visible from Earth, suggesting a reddish coloration similar to Mars but significantly more luminous during its approach. The colour description appears consistently across multiple independent sources, with variations that suggest systematic observation rather than conventional religious symbolism. The comparison to copper, particularly heated or oxidized copper, indicates a colour in the red-orange portion of the spectrum that modern planetary science associates with iron oxide compounds in surface materials or atmospheric dust. Mars exhibits its characteristic reddish colour due to iron oxide in its surface regolith, and similar mineralogy on Nibiru could produce comparable coloration. However, the texts emphasize that Nibiru's colour appears more vivid and luminous than Mars, describing it as copper that has drunk the fire of the forge, or the ruddy glow of sunset magnified 10,000 times, suggesting either closer approach distances that make the colour more apparent, or intrinsic differences in surface composition that produce more intense coloration. The brightness measurements provided in the astronomical tablets employ the Mesopotamian magnitude system based on comparison with reference stars and planets. The brightest celestial objects receive the designation first magnitude, with progressively dimmer objects assigned higher magnitude numbers. Venus, the brightest planet visible from Earth, served as the primary reference point for brightness comparisons. The tablets describe Nibiru at its maximum brightness as exceeding Venus by the measure of 4 watches, an expression that modern astronomical analysis interprets as indicating Nibiru appeared approximately 4 magnitudes brighter than Venus at its brightest. This brightness level would make Nibiru visible in full daylight and bright enough to cast shadows at night, creating a celestial spectacle without parallel in the historical record except during exceptional astronomical events like supernova appearances or extremely close comet passages. The physical size estimates derived from brightness and distance calculations suggest Nibiru possesses diameter and mass substantially greater than Earth, but smaller than the gas giants Jupiter and Saturn. Tablet BM 45623 contains geometric calculations that estimate the planet's angular diameter during its closest approach to Earth. These measurements, expressed in the Mesopotamian unit called the quote, 32 quote used for small angular measurements, translate to an apparent size approximately 1/4 that of the full moon. When combined with distance estimates derived from parallax observations recorded in the same tablet series, these angular measurements indicate an actual diameter roughly 4 times that of Earth, placing Nibiru in the category that modern planetary science terms _quote, _33 rocky planets, significantly larger than Earth but smaller than Neptune. The mass estimates provided through gravitational effect calculations suggest Nibiru possesses mass approximately 5 to 7 times that of Earth. These mass determinations derive from observations of perturbations in the orbits of Mars and Jupiter during Nibiru's perihelion passage, with the magnitude of orbital disruptions indicating the strength of Nibiru's gravitational field. Tablet K 3461 describes how quote 34, referring to observable changes in Mars's position during Nibiru's approach. The mathematical analysis of these perturbations preserved in the tablet yields mass estimates that modern orbital mechanics confirms are consistent with the described effects, demonstrating that Babylonian astronomers understood gravitational interactions and could calculate relative planetary masses from observed orbital changes. The surface gravity calculations that follow from the size and mass estimates indicate Nibiru possesses gravitational field strength approximately 2 to 2.5 times that of Earth. The tablets address this characteristic indirectly through descriptions of biological adaptations required for Anunnaki beings to function effectively on Earth's surface. Medical and physiological texts describe the weakness of the earthbound ones, who struggle with Earth's lower gravity after extended periods on their homeworld, requiring structured physical conditioning and sometimes mechanical assistance to maintain strength and endurance. The reverse adaptation problem, humans or Earth-adapted beings attempting to function on Nibiru, would be even more severe, with the higher gravity creating difficulties in movement, circulation, and skeletal stress that would require either genetic adaptation or technological support systems. The density calculations derived from mass and volume estimates suggest Nibiru possesses mean density approximately 1.7 times that of Earth, indicating a planet with substantial iron core surrounded by thick silicate mantle and crust. This internal structure would generate powerful magnetic fields through dynamo action as the molten iron core rotates within the planet's gravitational field. The strength of this magnetic field receives explicit attention in later segments, discussing protective properties against cosmic radiation, but the fundamental physics deriving from the planet's size, mass, and composition determine the magnetic field characteristics that make Nibiru habitable despite its unusual orbit. The combination of these physical properties creates a world dramatically different from Earth, yet capable of supporting complex life through mechanisms that balance the extreme variations in solar radiation experienced during its eccentric orbital journey. The Mesopotamian texts provide surprisingly detailed descriptions of Nibiru's atmospheric conditions that include information about pressure, composition, and optical effects that would require advanced scientific observation to determine. The Babylonian astronomical compendium known as Mul.Apin contains passages describing the planet's atmosphere as quote underscore 36 underscore and capable of quote underscore 37 underscore suggesting an atmosphere substantially denser than Earth's, with greenhouse properties that maintain temperature stability despite the planet's highly elliptical orbit. The atmospheric pressure estimates derived from these descriptions indicate surface pressures approximately 3 to 4 times greater than Earth's sea level atmospheric. Pressure. This higher pressure appears in multiple contexts throughout the cuneiform literature, particularly in medical texts that describe physiological adaptations required for beings accustomed to Nibiru's atmospheric conditions. Tablet CBS. 14,291 describes breathing difficulties experienced by Anunnaki personnel during their initial arrival on Earth. Characterizing the problem as quote underscore 38, that required adaptation periods during which the divine beings remained in specially constructed chambers that maintained higher atmospheric pressure. These acclimatization facilities, described in temple construction texts from Eridu and Nippur, incorporated sealed chambers with controlled environments that gradually reduced pressure over periods of weeks or months to allow biological adjustment to Earth's lower atmospheric density. The atmospheric composition descriptions provide specific information about constituent gases that demonstrate sophisticated understanding of atmospheric chemistry. The texts describe Nibiru's atmosphere as containing, quote, 39, clearly referring to oxygen or oxygen-rich gas mixtures, but emphasize that this life-sustaining component exists in higher concentrations than in Earth's atmosphere. Modern atmospheric science recognizes that oxygen partial pressure, rather than percentage composition, determines the gas's availability for respiration, and a denser atmosphere with similar oxygen percentage would provide greater absolute oxygen quantities. However, the tablets suggest not only higher pressure, but also higher oxygen concentration, describing the atmosphere as quote underscore 40 underscore, and noting that flames burn with unusual intensity on Nibiru's surface. The greenhouse gas content receives particular attention in passages explaining how Nibiru maintains habitable temperatures despite spending most of its orbital period in the frigid outer solar system. The texts describe atmospheric components that trap the sun's gift and hold it close to the land, and turn the warmth of stone and water into blessing for all that grows. These descriptions correspond remarkably with modern understanding of greenhouse gases like carbon dioxide, methane, and water vapor that absorb infrared radiation and prevent its escape to space. The tablet series, designated as the Wisdom of Concerning the Distant Home, provides the most detailed account of this atmospheric greenhouse effect, explaining that Nibiru's thick atmosphere containing high concentrations of these heat-trapping gases maintains surface temperatures warm enough for liquid water, even when the planet orbits far from the Sun where solar radiation provides minimal heating. The optical phenomena created by Nibiru's dense atmosphere receive extensive documentation in observational texts that describe the planet's appearance during its approaches to the inner solar system. The tablets note that Nibiru exhibits distinct atmospheric banding similar to Jupiter and Saturn, with alternating light and dark zones that circle the planet parallel to its equator. These bands, described as, quote, 44 or quote 45 result from atmospheric circulation patterns driven by the planet's rotation and the differential heating between equatorial and polar regions. The texts provide detailed descriptions of colour variations within these bands, ranging from pale cream and yellow tones in some zones to deeper orange and reddish hues in others, suggesting complex atmospheric chemistry involving various compounds that create different colorations through selective absorption and scattering of sunlight. Atmospheric dynamics descriptions include references to massive storm systems that persist for extended periods. Similar to Jupiter's Great Red Spot, but apparently more numerous on Nibiru, the texts describe quote 46 and quote 47 storm systems so large they remain visible from Earth during Nibiru's approach as distinct features against the planet's disk. These persistent storms indicate atmospheric conditions with tremendous energy content and stable circulation patterns that maintain coherent structures across timescales measured in years or decades. The driving energy for such storms presumably derives from internal heat sources within the planet, as solar heating alone would vary too dramatically across Nibiru's eccentric orbit to sustain stable atmospheric circulation patterns. Cloud formation and precipitation patterns receive attention in agricultural texts that describe the blessing of the sky waters that nourish Nibiru's surface. These descriptions indicate active hydrological cycles with cloud formation, precipitation, and surface water evaporation maintaining continuous atmospheric water content. The persistence of liquid water and active weather systems throughout Nibiru's orbit requires either substantial internal heat sources that maintain surface temperatures above water's freezing point or atmospheric pressure high enough that water remains liquid at lower temperatures. The combination of high atmospheric pressure and greenhouse warming likely contributes to maintaining habitable conditions across the orbital cycle, with these factors partially compensating for the enormous variations in solar radiation between perihelion and aphelion. The atmospheric shimmer and refraction effects noted in observational texts indicate substantial atmospheric depth and density gradients that bend light passing through Nibiru's atmosphere. These optical effects complicated accurate position measurements when the planet appeared near the horizon, requiring correction factors that Babylonian astronomers developed through systematic observation. The correction procedures, preserved in computational tablets, demonstrate understanding that atmospheric refraction increases near the horizon and that denser atmospheres produce stronger refraction effects. The magnitude of corrections applied to Nibiru observations exceeds those used for other planets, confirming the ancient observers recognized Nibiru possessed an unusually dense atmosphere that created distinctive optical phenomena. Several cuneiform tablets contain mathematical calculations that describe gravitational interactions between Nibiru and other solar system bodies during its periodic approaches to the inner planets. These calculations demonstrate understanding that gravitational force depends on both mass and distance, concepts that wouldn't be formally articulated until Isaac Newton's Principia Mathematica in 1687. The gravitational perturbation calculations preserved in tablet series K, 3458 through K, 3462 represent some of the most sophisticated mathematical astronomy found in ancient Mesopotamian sources. These texts describe observable changes in planetary positions that occur during Nibiru's perihelion passages, including alterations in Mars's orbital position, disruptions in Jupiter's satellite system, and measurable effects on Earth's orbital parameters. The mathematical framework employed expresses gravitational effects through proportional relationships that demonstrate understanding of the inverse square law governing gravitational force, though the Babylonian formulation uses geometric language rather than the algebraic expressions familiar to modern physics. The Mars perturbation calculations provide the most detailed worked examples of gravitational interaction mathematics. Tablet K, 3459, describes how Mars's position shifts from its predicted location during years when Nibiru passes through the inner solar system, with the magnitude of positional displacement depending on the relative positions of Mars and Nibiru at the time of closest approach. The tablet presents a computational procedure that calculates the angular displacement based on two key parameters: the distance between Mars and Nibiru at closest approach, and the ratio of their masses. The calculation method employs successive approximations that refine the displacement estimate through iterative calculations, a technique that demonstrates sophisticated mathematical problem-solving approaches. The mass ratio determination represents a crucial element in these calculations, as accurate prediction of gravitational effects requires knowledge of the relative masses of interacting bodies. The Babylonian astronomers determined mass ratios through careful observation of mutual perturbations between planets, noting that when two bodies pass near each other, both experience position shifts with magnitudes inversely proportional to their masses. By observing perturbations of Mars caused by Jupiter during close approaches and comparing these to perturbations caused by Nibiru, the ancient astronomers could calculate Nibiru's mass relative to Jupiter's mass. The results of these calculations, preserved in tablet BM 45893, indicate Nibiru possesses mass approximately 12 to 15% that of Jupiter, or roughly 60 to 75 times Earth's mass. This mass estimate significantly exceeds the 5 to 7 Earth mass estimate derived from size and density calculations, suggesting either measurement uncertainties in ancient observations or complexities in Nibiru's internal structure that create unexpectedly strong gravitational effects. The Jupiter satellite perturbations described in the astronomical texts provide additional evidence for gravitational interaction calculations. The tablets note that during Nibiru's perihelion passages, the orbital periods of Jupiter's moons show measurable changes that persist for several years before gradually returning to their normal values. This observation requires not only the ability to measure satellite orbital periods with high precision, but also the theoretical understanding that external gravitational forces can alter orbital parameters of bodies in the Jupiter system. The magnitude of satellite period changes described in the texts corresponds to what modern celestial mechanics calculates for gravitational perturbations from a massive body passing through the inner solar system at the distances and masses indicated in other Nibiru descriptions. Earth orbital parameter changes receive particular attention because of their potential effects on terrestrial climate and seasonal patterns. The tablets describe subtle alterations in the length of the year, changes in seasonal intensity, and shifts in the timing of equinoxes and solstices that occur during Nibiru approach periods. These effects indicate that Nibiru's gravitational field perturbs Earth's orbit, slightly altering its shape and orientation in ways that affect the planet's climate system. The text series known as the Warnings of Ea Concerning the Star of Return specifically addresses these climate disruptions, providing guidance for agricultural planning during years when Nibiru's gravitational effects alter growing seasons and precipitation patterns. The tablet calculations also address tidal effects caused by Nibiru's gravitational field acting on Earth's oceans and solid body. The texts describe quote 50 that occurs when Nibiru approaches closest to Earth, with coastal regions experiencing unusually high tides that can exceed normal tidal ranges by factors of 3 to 5. These extreme tidal effects result from Nibiru's strong gravitational field, creating substantial differential forces across Earth's diameter, similar to the mechanism by which the Moon generates regular tides, but amplified by Nibiru's greater mass during close approach. The combination of gravitational tides and atmospheric pressure changes can generate massive storm surges that inundate coastal areas, effects that appear in Mesopotamian flood narratives as components of the catastrophic deluge that destroyed antediluvian civilization. Solid Earth tides, the deformation of Earth's rocky body under external gravitational forces, receive attention in texts describing increased earthquake and volcanic activity during Nibiru approach periods. The tablets note that, quote, 51 and, quote, 52, when the great planet draws near, effects consistent with tidal stresses triggering seismic activity and volcanic eruptions. Modern geophysics recognizes that external gravitational forces can influence timing of earthquakes and volcanic events by adding stress to already loaded fault systems and magma chambers, causing them to release accumulated energy during periods of peak tidal stress. The correlation between Nibiru approaches and global catastrophic events described in Mesopotamian flood narratives may reflect the planet's gravitational effects, triggering simultaneous geological disasters across multiple regions. The astronomical texts include descriptions of Nibiru's surface features that suggest direct observation, or detailed reporting from sources who had observed the planet closely. Tablet K, 3,460, describes the planet's surface as containing mountains that touch the sky, and valleys deeper than the abyss, suggesting dramatic topographical variation with elevations that exceed Earth's mountain ranges. The mountain descriptions provide specific details about height, appearance, and geographical distribution that indicate systematic observation rather than mythological invention. The texts describe mountain ranges that encircle the planet's polar regions, forming crowns of stone upon the brow of the world, with peaks that rise to heights described as 10,000 cubits above the Great Plains. Converting the cubit measurement, approximately half a metre in Mesopotamian standards, yields mountain heights of approximately 5,000 metres. Comparable to Earth's highest peaks, but apparently more extensive and numerous on Nibiru. The formation of such massive mountain ranges requires tectonic forces and crustal dynamics that indicate Nibiru remains geologically active despite its age, with continuing plate tectonics and volcanic activity reshaping the surface across geological timescales. The valley descriptions emphasize depth and scale that exceed terrestrial features, with the texts referring to, quote, 57 and, quote, 58. These descriptions suggest extensive rift valley systems similar to Earth's East African Rift, or oceanic spreading centres, but apparently on larger scale, consistent with a more massive planet experiencing vigorous tectonic activity. The formation mechanisms for such deep valleys on a high-gravity world like Nibiru would require tremendous crustal stresses and potentially different tectonic processes than those operating on Earth, as the higher surface gravity would resist vertical displacement and favour horizontal tectonic motion. Surface colour variations receive detailed attention in observational texts that describe distinct geographical regions with different hues and reflective properties. The tablets distinguish between the ruddy lands of the south, characterised by red and orange colorations, the golden plains of the equatorial realm, exhibiting yellow and tan tones, and the pale highlands of the north, showing lighter cream and white colours. These regional colour variations suggest different surface compositions and mineralogies across different latitudinal zones, possibly resulting from climate-driven weathering processes that produce different mineral assemblages under varying temperature and moisture conditions. The presence of iron oxides producing red colorations indicates oxidizing conditions at some point in Nibiru's history, implying atmospheric oxygen content sufficient for mineral oxidation processes. Volcanic features receive extensive documentation in texts describing, quote, 62 and, quote, 63. These descriptions indicate active volcanism produces prominent landscape features including stratovolcanoes, volcanic fields, and extensive lava flows that cover substantial surface areas. The scale of volcanic features described in the tablets suggests volcanic activity more vigorous than contemporary Earth volcanism, possibly driven by stronger internal heat sources and more efficient heat transport mechanisms within the planet's interior. The connection between volcanism and atmospheric composition appears in texts that attribute Nibiru's dense greenhouse atmosphere partially to volcanic outgassing that continuously replenishes atmospheric carbon dioxide and other volcanic gases. Impact crater descriptions appear in passages referring to quote 64 and quote 65, indicating Nibiru's surface preserves evidence of meteor impacts accumulated over its history. The preservation of impact craters requires either absence of erosional processes that would erase such features, or impact rates high enough that crater formation outpaces erosion. Given that the tablets also describe active weather systems and surface water that would drive erosion, the visibility of impact features suggests relatively recent formation or unusually large crater sizes that resist erosional degradation. The text describes some impact sites as possessing special significance, with certain craters designated as sacred locations where heaven touched earth and left lasting marks. Polar region descriptions emphasize ice and snow coverage that extends to mid-latitudes during portions of Nibiru's orbital cycle, creating _quote_67_. These polar ice caps indicate water ice accumulation at high latitudes where temperatures remain below freezing, even with greenhouse warming effects. The seasonal variations in ice cap extent reflect Nibiru's axial tilt, and the resulting differential solar heating between summer and winter hemispheres. Though the magnitude of seasonal variations would be dramatically amplified by the orbital eccentricity that causes total solar radiation received by the planet to vary enormously between perihelion and aphelion passages. Desert regions receive description as the great dry lands where water sleeps beneath the sands, indicating extensive arid zones where surface water is absent, but subsurface aquifers maintain groundwater resources. The existence of desert regions on a planet with active hydrological cycles suggests atmospheric circulation patterns that create rain shadows, or moisture transport mechanisms that concentrate precipitation in certain regions while leaving others dry. The texts describe these deserts as containing ancient dried lake beds and channels where rivers once flowed, suggesting past climate conditions differed from present conditions, possibly reflecting long-term climate evolution, as Nibiru's orbit gradually changes under gravitational perturbations from Jupiter and Saturn. Oceanic features appear in descriptions of quote 70 and quote 71. These references to planet-spanning oceans indicate substantial surface water coverage. Though the relative proportions of land and water remain unclear from tablet descriptions, the existence of extensive oceans requires liquid water stability across a wide temperature range, consistent with high atmospheric pressure that elevates water's boiling point and prevents evaporation even at elevated temperatures. The ocean descriptions include references to the warm currents that flow from the fire mountains beneath the waves, suggesting submarine volcanic activity and hydrothermal systems that release heat into the oceans and contribute to maintaining stable water temperatures. The term Planet of the Crossing derives from Nibiru's described intersection with the plane of the solar system at a specific point in its orbit that the tablets locate between the orbits of Mars and Jupiter. This crossing point, described with considerable mathematical precision in multiple sources, corresponds to what modern astronomy recognizes as the asteroid belt, a region of space populated by countless rocky fragments that some researchers have theorized might represent the remnants of a destroyed planet. The geometric configuration of Nibiru's orbit relative to the plane of the solar system receives detailed mathematical treatment in Tablet Series B, M34560 through BM 34568. These texts describe orbits in three-dimensional space using coordinate systems that specify positions through combinations of angular measurements and distance estimates. The solar system plane, termed the path of Anu in the tablets, serves as the fundamental reference surface from which other orbital positions are measured. The 5 visible planets follow orbits that remain close to this reference plane, deviating by only a few degrees in inclination, creating the appearance from Earth that all planets move through the same narrow band of constellations forming the zodiac. Nibiru's orbital inclination receives specific quantitative description, indicating the orbit tilts approximately 30 degrees relative to the solar system plane. This substantial inclination means Nibiru spends portions of its orbit high above the plane and other portions far below, crossing through the plane at two specific points called the ascending node, where the planet moves from south to north of the plane, and the descending node where it moves from north to south. The tablets focus particular attention on the ascending node crossing, which occurs when Nibiru passes through the plane while moving inward toward perihelion, making this the primary visibility phase when the planet becomes observable from Earth. The location of this crossing point receives precise specification through its position relative to known planetary orbits and constellation backgrounds. The texts consistently place the crossing point _quote _75 using the Sumerian names for Mars and Jupiter respectively. This location corresponds to what modern astronomy calls the asteroid belt, a region extending from approximately 2.2 astronomical units from the Sun, just beyond Mars's orbit at 1.5 astronomical units, to approximately 3.3 astronomical units, just inside Jupiter's orbit at 5.2 astronomical units. The precision with which the tablets specify this location, including angular coordinates measured against background stars, indicates the Babylonian astronomers had determined the crossing point through actual observation of Nibiru transiting this region during previous perihelion passages. The significance of the asteroid belt location receives additional attention in creation mythology that describes cosmic battles between Marduk and Tiamat that allegedly resulted in Tiamat's destruction and the formation of Earth and the asteroid belt from her remains. While conventional scholarship interprets this narrative as pure mythology, alternative analysis suggests it preserves encoded information about actual planetary dynamics and possibly catastrophic events in solar system history. The correlation between mythological descriptions of planetary destruction and the actual existence of a debris field at the exact location where the tablets place Nibiru's crossing point suggests the ancient accounts may preserve genuine historical information about solar system evolution and possibly violent planetary interactions that reshaped the inner solar system structure. Modern astronomical research into asteroid belt origins has produced various formation theories, with most mainstream models suggesting the asteroids represent planetesimals that never accreted into a planet due to gravitational perturbations from nearby Jupiter. However, alternative theories propose the asteroid belt might represent fragments of a destroyed planet that was disrupted through catastrophic collision or tidal forces. The chemical and physical properties of asteroids show diverse compositions suggesting they originated from different depths within a differentiated body, consistent with fragmentation of a planet with distinct core, mantle, and crustal layers. The Mesopotamian tablets describing Nibiru's crossing point at this exact location, and mythological narratives describing planetary destruction, provide intriguing correlation with physical evidence of a disrupted planet. The gravitational effects of Nibiru passing through the asteroid belt during each perihelion passage would produce significant perturbations on asteroid orbits, potentially scattering some asteroids into Earth-crossing orbits, where they could impact the inner planets. This mechanism could explain the correlation between Nibiru approach periods and catastrophic impact events described in Mesopotamian flood narratives and other ancient catastrophe accounts. The tablets explicitly connect Nibiru approaches with showers of fire from heaven and stones that fall from the sky, descriptions consistent with enhanced meteorite bombardment caused by gravitational stirring of the asteroid belt during Nibiru passages. The orbital geometry that produces the crossing phenomenon receives mathematical analysis in tablets that calculate the timing and duration of Nibiru's passage through the plane. The texts indicate the planet remains within the plane, defined as the region within 1 degree above or below the reference surface, for a period of several months centered on perihelion. During this crossing period, Nibiru would be maximally visible from Earth as the planet passes relatively close to our world, while also receiving maximum solar illumination near its perihelion position. The combination of close approach distance and high illumination creates optimal visibility conditions that explain why ancient observers could document Nibiru's characteristics in such detail, despite the planet's usual remoteness in the outer solar system. Advanced passages in the astronomical tablets describe Nibiru as possessing what they term, quote, 78 a phenomenon that appears to reference a powerful magnetic field that shields the planet's surface from harmful cosmic radiation. The texts indicate this magnetic field is substantially stronger than Earth's, describing it as capable of, quote, 79, quote-unquote 80, quote. The magnetic field strength estimates derived from these descriptions indicate surface magnetic field intensity approximately 10 to 20 times greater than Earth's field. This powerful magnetic field generates from dynamo action within Nibiru's iron core, driven by convective currents in molten metallic material that create electrical currents producing the magnetic field. The strength of planetary magnetic fields depends on several factors including core size, rotation rate, and internal heat flow, all of which appear favourable for strong field generation on Nibiru. The planet's large iron core resulting from its substantial mass, combined with reasonably rapid rotation and vigorous internal convection, driven by radiogenic heating and gravitational differentiation, creates conditions for powerful dynamo action that maintains the described strong magnetic field. The radiation shielding function of this magnetic field receives particular emphasis in texts explaining how Nibiru maintains habitable surface conditions despite spending most of its orbit in regions of space where solar wind protection is minimal and cosmic radiation intensity is high. The arrows of the sun referenced in the texts correspond to what modern space physics terms the solar wind, the continuous stream of charged particles emitted by the sun that flows outward through the solar system. Earth's magnetic field deflects these charged particles around the planet, preventing them from reaching the surface where they would damage biological molecules and make surface conditions inhospitable to life. Nibiru's stronger magnetic field provides even more effective protection, creating a larger magnetosphere that deflects solar wind and cosmic radiation across a broader region around the planet. The shape and structure of Nibiru's magnetosphere receive description in passages that characterize it as, quote, 82 and, quote, 83. These descriptions correspond remarkably with the actual geometry of planetary magnetospheres as understood by modern space physics. Magnetic field lines emerge from one magnetic pole, arc through space around the planet, and return to the opposite pole, creating a dipole field structure that resembles a three-dimensional bowl or embracing wings. The size of this magnetosphere, the region within which the planetary magnetic field dominates over external fields, scales with magnetic field strength, so Nibiru's powerful field would create a magnetosphere extending several planetary radii into space, providing extensive protection for the planet and any spacecraft operating in near Nibiru space. The interaction between Nibiru's magnetic field and the solar wind produces visible phenomena described in the tablets as, quote, 84 and, quote, 85. These descriptions correspond precisely with auroral displays caused when charged particles from the solar wind become trapped in magnetic field lines and spiral down toward the magnetic poles, exciting atmospheric gases that emit visible light. The colours described in the texts, including quote 86 and quote 87, match the emission spectra of oxygen and nitrogen gases excited by particle bombardment, the same processes that generate Earth's auroral displays, but apparently more intense and frequent on Nibiru due to the stronger magnetic field and potentially different atmospheric composition. The magnetic field strength variations across Nibiru's surface receive attention in texts describing, quote, 88, quote, and regions where, quote, 89, quote. These descriptions suggest the ancient observers recognized that magnetic field strength varies across the planetary surface, reaching maximum intensity near the magnetic poles and minimum strength at the magnetic equator. The texts indicate certain geographical locations possess special magnetic properties. possibly areas where magnetic minerals in surface rocks create local field anomalies, or regions where the global field exhibits unusual characteristics. These magnetically special locations receive designation as sacred sites, where temples and communication facilities were preferentially constructed, suggesting the Anunnaki recognized practical applications for strong magnetic field effects. The temporal variations in Nibiru's magnetic field receive documentation in passages describing how the cloak of protection waxes and wanes with the great cycles, and experiences reversals where north becomes south and south becomes north. These descriptions demonstrate understanding that planetary magnetic fields undergo both gradual strength changes and occasional polarity reversals where the magnetic north and south poles exchange positions. Earth's magnetic field exhibits similar behavior, with paleomagnetic studies revealing the field has reversed polarity hundreds of times throughout geological history. The Mesopotamian texts suggest Nibiru's magnetic field also undergoes reversals, though the frequency and timing of these events remains unclear from available descriptions. The recognition of magnetic field temporal variations indicates sustained observation over extended periods sufficient to detect long-term magnetic changes. The cuneiform descriptions consistently portray Nibiru as a life-supporting world with abundant water resources despite its extended periods in the outer solar system. Tablet CBS.11227 describes the planet as containing great seas that never freeze and rivers that flow with the wisdom of the ancients, suggesting liquid water exists on the surface throughout the orbital cycle. The hydrological descriptions provide detailed accounts of water distribution across Nibiru's surface that indicate a complete water cycle operating continuously despite the planet's eccentric orbit and resulting extreme variations in solar radiation. The texts describe extensive ocean basins covering what they estimate as 2 parts of 3 of the planetary surface, suggesting water coverage comparable to or exceeding Earth's 71% ocean coverage. These ocean descriptions emphasize their persistence as liquid bodies throughout the orbital cycle, with the phrase, quote, 95 explicitly indicating the water remains in liquid phase even during aphelion when Nibiru orbits in the frigid outer solar system far from the sun's warmth. This remarkable characteristic requires explanation through either substantial internal heat sources that warm the oceans from below, or atmospheric greenhouse effects so powerful they maintain surface temperatures above water's freezing point despite minimal solar heating. The river systems described in the tablets appear to rival or exceed Earth's major river networks in scale and extent. The texts refer to rivers broader than the Euphrates and Tigris combined, that flow across continental landmasses carrying water from highland regions to the seas. The description of rivers that flow with the wisdom of the ancients appears to reference not only their physical characteristics, but also their role in supporting civilization and agriculture on Nibiru, paralleling the crucial importance of rivers like the Tigris and Euphrates for Mesopotamian civilization. The sustained flow of these rivers throughout Nibiru's orbital cycle indicates continuous precipitation and runoff, maintained by active atmospheric circulation and water vapor transport from oceans to continental interiors. Lake and inland sea descriptions appear in passages referring to quote 98 and quote 99. These features suggest Nibiru possesses extensive systems of freshwater lakes, comparable to Earth's Great Lakes, or even larger inland seas rivaling the Caspian Sea in size. The persistence of these freshwater bodies indicates they receive continuous input from precipitation and river systems, while experiencing evaporation rates that don't exceed inflow, maintaining stable water levels across long timescales. The text describes some of these lakes as possessing special properties, including unusual clarity that allows vision to quote 100 or mineral content that creates distinctive colors, described as quote 101 or quote 102. Groundwater resources receive attention in texts describing quote 103 and quote 104. These descriptions indicate extensive aquifer systems within Nibiru's crust that store substantial water volumes and feed surface springs and wells that provide water resources even in regions distant from rivers and lakes. The characterization of these groundwater sources as eternal suggests they maintain stable flow rates across extended periods, possibly recharged by deep circulation systems that connect surface water with water stored in deeper crustal or mantle reservoirs. Some texts describe particularly important springs as emerging from great depths and possessing unusual temperatures or mineral content that distinguishes them from ordinary groundwater sources. Precipitation patterns described in the tablets indicate regular rainfall cycles that distribute water across Nibiru's surface, with geographical variations creating wetter and drier regions similar to Earth's climate zones. The texts describe lands where rain falls without ceasing, that support lush vegetation and dense forests, contrasted with the dry lands where water comes only with the turning of the seasons, that experience distinct wet and dry periods. The existence of these varied precipitation patterns indicates atmospheric circulation cells and moisture transport mechanisms that create regional climate variations despite the planet's overall ability to maintain stable global temperatures. Ice and snow descriptions focus primarily on polar regions and high-altitude areas where surface temperatures remain below freezing even with greenhouse warming and internal heating. The texts describe, quote, 108, quote, and quote, 109, quote, that persist throughout the orbital cycle, indicating permanent ice caps at the poles and glaciers in high mountain regions. However, the emphasis on these ice features is limited to specific geographical areas rather than covering extensive portions of the planet, confirms that most of Nibiru's surface maintains temperatures well above freezing, supporting the liquid water bodies described elsewhere in the texts. The water chemistry descriptions indicate Nibiru's oceans possess salinity and mineral content different from Earth's oceans. The texts describe seas bitter, with salt beyond that of earthly waters, and oceans containing dissolved minerals that create distinctive colours and properties. Some passages suggest certain Nibiruan seas possess lower salinity than Earth's oceans, described as, quote, 111 that remain liquid but contain less dissolved salt. These variations in ocean chemistry might reflect different geological processes controlling mineral input to the oceans, or different evaporation-precipitation balances that concentrate salts to varying degrees in different ocean basins. Tidal phenomena receive description in passages that reference, quote, 112 and, quote, 113. These descriptions indicate Nibiru's oceans experience tidal cycles despite the planet's presumed lack of large moons comparable to Earth's moon that generates most terrestrial tides. The tidal forces must therefore originate from either smaller satellites orbiting Nibiru or from the Sun's gravitational field during perihelion passages, when solar tides could generate measurable ocean surface variations. Some texts suggest Nibiru possesses, quote, 114, quote, possibly referring to satellites that contribute to tidal forces and create the described tidal cycles. The tablets that describe Nibiru also document the biological and physiological challenges the Anunnaki faced when establishing their presence on Earth, providing indirect evidence about conditions on their home world through descriptions of necessary adaptations. Medical texts from the Old Babylonian period preserved in the Yale Babylonian collection describe treatments for what they term underscore, quote, underscore 115, underscore conditions affecting divine beings who spent extended periods on Earth's surface. The adaptation challenges stemmed primarily from differences in gravitational field strength, atmospheric pressure and composition, day-night cycle duration, and radiation environment between Nibiru and Earth. Tablet YBC 4739 provides the most comprehensive medical documentation of these adaptation syndromes, describing a progression of symptoms that affected Anunnaki personnel during their initial months on Earth's surface. The condition termed underscore, quote, underscore 116 underscore manifested as muscular atrophy, skeletal density loss, and cardiovascular deconditioning resulting from Earth's lower gravity compared to Nibiru's 2 to 2.5 times stronger gravitational field. Divine beings accustomed to functioning under high gravity experienced Earth's lower gravity as a form of weightlessness that required significant physiological adjustments. The medical texts describe treatment protocols involving structured exercise programs designed to maintain muscle mass and bone density despite reduced gravitational loading. These protocols specified daily labours of prescribed heaviness, requiring Anunnaki personnel to perform physical tasks while wearing weighted garments or manipulating heavy objects that artificially recreated the resistance forces they would experience on Nibiru. The exercise prescriptions included specific durations and intensities calibrated to individual needs, demonstrating sophisticated understanding of exercise physiology and the principles of gravitational adaptation. Some texts describe mechanical devices termed the weights of return preparation that provided resistance exercise through systems of counterweights and levers, functioning as ancient equivalents of modern resistance training equipment. Cardiovascular adaptation challenges received particular attention in passages describing the racing of the heart and weakness of the blood vessels that affected newly arrived Anunnaki. The lower gravity environment reduced the work required for the cardiovascular system to pump blood throughout the body, leading to cardiac deconditioning and blood vessel changes that could cause problems when divine beings eventually returned to Nibiru's higher gravity. The medical texts prescribed cardiovascular conditioning activities, including quote 121 and quote 122, designed to maintain cardiac fitness despite the reduced gravitational stress. Respiratory adaptation problems stem from Earth's lower atmospheric pressure and different oxygen concentration compared to Nibiru's denser atmosphere. The condition termed __quote_123 manifested as shortness of breath during exertion and a sensation of insufficient oxygen intake, despite Earth's atmosphere containing adequate oxygen for sustaining life. The adaptation protocols included gradual acclimatization procedures where newly arrived Anunnaki spent initial periods in pressurized chambers that replicated Nibiru's atmospheric conditions, with pressure gradually reduced over weeks or months to allow physiological adjustment to Earth's thinner atmosphere. The texts describe these acclimatization facilities as the houses of measured breath, equipped with mechanical systems that controlled internal atmospheric pressure through methods involving sealed chambers and pumping devices that added or removed air to adjust pressure levels. Circadian rhythm disruptions resulted from the difference between Nibiru's 26-hour day-night cycle and Earth's 24-hour day. The 2-hour difference might seem minor, but the cumulative effect over weeks and months could significantly disrupt biological rhythms governing sleep-wake cycles, hormone secretion patterns, and metabolic functions. The medical texts describe the confusion of proper time affecting sleep quality and daily energy patterns, with treatments involving carefully structured daily schedules that gradually shifted timing of activities to align with Earth's shorter day. Some texts mention use of specific herbs and substances that facilitated sleep regulation and helped reset disturbed circadian rhythms. Radiation environment differences created additional challenges, documented in texts describing increased sensitivity to solar radiation among Anunnaki adapted to Nibiru's stronger magnetic field protection. Earth's weaker magnetic field and thinner ozone layer allowed higher levels of ultraviolet radiation to reach the surface compared to Nibiru's conditions. The medical condition termed the burning of heaven's light described skin damage and eye problems resulting from unaccustomed solar radiation exposure. Treatment protocols included protective garments, mineral-based skin coatings that blocked ultraviolet light, and gradual exposure programs that allowed development of natural protective responses, including increased skin pigmentation. Dietary adaptation requirements received documentation in texts describing metabolic differences between Anunnaki physiology and typical human nutritional needs. The passages suggest divine beings required different proportions of nutrients or different total caloric intake to maintain optimal function on Earth, compared to Nibiru. Some texts describe specific foods that strengthened the earthbound ones and helped maintain proper physiological function, while others warn against certain Earth foods that disagreed with divine constitutions and caused digestive distress or metabolic disruptions. The existence of these dietary specifications indicates significant biochemical differences between Anunnaki and human metabolic systems despite the genetic compatibility that allowed interbreeding between the two populations. Psychological adaptation challenges appear in passages describing emotional and cognitive effects of prolonged Earth residence. The condition termed the longing for the distant home encompass symptoms modern medicine would recognize as depression, anxiety, and adjustment disorders resulting from separation from familiar environments and social networks. The texts describe this condition as particularly severe among Anunnaki assigned to lengthy Earth tours spanning decades or centuries. With some individuals experiencing such profound distress, they became unable to perform assigned duties effectively. Treatment approaches included periodic return visits to Nibiru during perihelion passages, participation in ritual observances that maintained connection with home culture, and structured social support systems within Earth-based Anunnaki communities. The reverse adaptation challenges, problems experienced when returning to Nibiru after extended Earth residence, received equal attention in medical texts warning that those who dwell long upon the Earth forget their proper strength and suffer greatly upon return. The readaptation to higher gravity, denser atmosphere, and longer days required structured protocols similar to initial Earth adaptation, but often more difficult due to deconditioning that occurred during Earth residence. The texts describe return preparation programs beginning months before scheduled departure, involving progressive increases in exercise intensity and use of pressure chambers that gradually increased atmospheric pressure to approach Nibiru conditions. Astronomical calculations preserved in the tablets provide information about Nibiru's rotational period and its implications for the day-night cycle experienced by inhabitants. The texts indicate the planet completes one rotation approximately every 26 Earth hours, creating days slightly longer than those on Earth, but falling within a range that would allow relatively easy adaptation for beings accustomed to either world. The rotational period determination appears in multiple independent sources that demonstrate different observational and computational methods, all converging on remarkably consistent values. Tablet BM 32416 contains the most detailed rotational analysis, describing how Babylonian astronomers measured Nibiru's rotation by tracking the movement of surface features across the planet's disk during its perihelion passages when the planet appeared large enough for surface details to be resolved. The observational procedure involved noting the position of distinctive surface markings relative to the planet's limb at specific times, then tracking how these features moved as the planet rotated. By measuring the time required for a specific feature to complete one full rotation and return to its starting position, the astronomers determined the rotational period. The measurement precision achieved through this method indicates observational capabilities that substantially exceed conventional expectations for ancient naked-eye astronomy. The texts specify rotational periods measured in watches and fingers, Mesopotamian time units where 1 watch equals 2 hours, and fingers represent fractions of watches. The calculations yield rotational periods of 13 watches, or 26 hours, with some tablets providing additional precision specifying 13 watches and 1 finger, suggesting refinement to approximately 26½ hours. The consistency of these measurements across multiple observation cycles and different perihelion passages demonstrates systematic observational programs that accumulated data over extended periods to achieve high-precision measurements. The day-night cycle characteristics resulting from this rotational period receive description in texts that compare Nibiru's daily rhythm to Earth's familiar pattern. The passages emphasize that the day of the Sky Lords exceeds the day of the Earth by the measure of 1 watch, explicitly quantifying the 2-hour difference between Nibiru's 26-hour day and Earth's 24-hour day. This relatively modest difference meant that biological organisms evolved on either world could adapt to the other's day-night cycle without extreme difficulty. Though some physiological adjustment would be required as documented in the medical texts describing Anunnaki adaptation challenges, the seasonal day-length variations that occur on planets with tilted rotational axes receive attention in passages describing how __135_. These descriptions indicate Nibiru possesses significant axial tilt that creates seasonal variations in day length, similar to those experienced on Earth. The text provides specific measurements indicating maximum day length. At summer solstice exceeds minimum day length at winter solstice by _136_8 hours for regions located at mid-latitudes. This day length variation corresponds to axial tilts in the range of 30 to 40 degrees, somewhat larger than Earth's 23½ degree axial tilt, creating more pronounced seasonal day length changes. The relationship between rotation period and orbital period determines how many days occur in Nibiru's year. The tablets calculate that Nibiru's 3,600-year orbital period contains approximately 1,200,000 planetary rotations, yielding a year of 1,200,000 days, each lasting 26 Earth hours. This extraordinary year length means seasons measured in days would span hundreds of thousands of days, though the extreme orbital eccentricity complicates simple seasonal patterns based on axial tilt alone. The text suggests Nibiru inhabitants used calendar systems based on the rotational day as the fundamental unit, with larger time divisions defined by astronomical phenomena rather than seasonal cycles. The rotational stability measurements preserved in the tablets indicate Nibiru maintains consistent rotational period without significant variations over observable timescales. This stability suggests the planet possesses sufficient mass and compact mass distribution that tidal forces from the Sun don't significantly affect its rotation rate. The texts explicitly note this stability, describing how, _137, unlike Earth's gradually lengthening day, caused by tidal interactions with the Moon. The absence of large satellites orbiting Nibiru eliminates the primary mechanism that creates long-term rotational changes on Earth, allowing Nibiru to maintain stable rotational period across geological timescales. The implications of the 26-hour day for biological rhythms and daily activity patterns receive consideration in texts describing typical daily schedules and activity distributions. The passages suggest Nibiru inhabitants naturally divide their days into activity and rest periods, roughly proportional to those familiar on Earth, with the time of labour occupying approximately 2/3 of the day, and the time of rest comprising the remaining 1/3. This division yields approximately 17 hours of waking activity and 9 hours of sleep, somewhat longer than typical human patterns, but falling within the range of normal variation observed across different human cultures and individuals. Despite Nibiru's highly elliptical orbit, which would typically create extreme seasonal variations as the planet moved between perihelion and aphelion, the tablets describe remarkably stable surface conditions maintained throughout the orbital cycle. This climatic stability, seemingly contradicting basic orbital mechanics, is attributed in the text to what they describe as __140, suggesting internal heat generation that supplements solar radiation and maintains habitable temperatures even during the planet's extended journey through the outer solar system. The internal heat source descriptions appear in multiple contexts throughout the cuneiform literature, with varying levels of technical detail that collectively paint a picture of vigorous internal heat generation mechanisms operating within Nibiru's deep interior. Tablet K, 3463, contains the most explicit discussion of these heat sources, describing how _141 and _142 These passages clearly indicate ongoing heat generation within Nibiru's interior rather than merely residual heat left over from the planet's formation, as the latter would have radiated away over geological timescales, leaving the planet frozen. The mechanisms generating this internal heat receive description through references to, quote, 143 and, quote, 144. Modern planetary science recognizes two primary sources of long-term planetary heat generation: radioactive decay of elements like uranium, thorium, and potassium incorporated into the planet during its formation, and residual heat from gravitational differentiation as dense materials sink toward the core while lighter materials rise toward the surface. The tablet descriptions appear to reference radioactive heating through phrases like, quote, 145 and, quote, 146 characteristics that match radioactive materials that generate heat through nuclear decay processes occurring at the atomic level without visible fire or combustion. The heat distribution mechanisms that transport this internally generated warmth from the deep interior to the surface receive detailed attention in texts describing, quote, 147, quote, and, quote, 148, quote. These descriptions correspond to mantle convection processes recognized by modern geophysics, where heat transport occurs through slow circulation of semi-molten rock that rises when heated, moves laterally beneath the crust, cools, and sinks back toward the core in continuous convection cells. The efficiency of this heat transport system determines how effectively internal heat reaches the surface, where it can contribute to maintaining habitable temperatures. The volcanic activity described throughout the tablet serves as the primary mechanism for delivering internal heat to the surface and atmosphere. The, quote, 149 that, quote, 150 function as heat vents that continuously release thermal energy from the planet's interior. The scale and intensity of Nibiru's volcanism, described as exceeding Earth's volcanic activity, indicates particularly vigorous internal heat generation and efficient transport mechanisms. The volcanic emissions include not only molten rock, but also vast quantities of volcanic gases, including carbon dioxide, water vapor, and other compounds that contribute to maintaining the dense greenhouse atmosphere described in earlier passages. The ocean floor volcanic systems receive particular emphasis in texts describing the fire mountains beneath the seas and vents where molten stone meets water. These submarine volcanic systems, analogous to Earth's mid-ocean ridges and hydrothermal vent fields, release enormous quantities of heat directly into the oceans, where it efficiently distributes through ocean circulation systems. The heated seawater rises, driving circulation patterns that transport warmth throughout the ocean basins and prevent freezing even during aphelion periods when surface cooling would otherwise freeze the seas. The texts describe how these submarine heat sources maintain ocean temperatures quote 153 indicating biologically favorable temperatures persist year-round. The geothermal gradient measurements, the rate at which temperature increases with depth beneath the surface, receive documentation suggesting Nibiru possesses temperature gradients substantially steeper than Earth's typical values. The texts describe how mines reaching modest depths encounter heat that makes labour difficult, and how wells dug for water often yield warm or hot springs. These observations indicate that relatively shallow depths beneath the surface reach elevated temperatures consistent with high heat flow from the interior. The practical implications for Nibiru inhabitants included extensive use of geothermal energy for heating buildings, processing materials, and other applications where thermal energy was required. The climate stability mechanisms that result from internal heating include buffering against the extreme solar radiation variations that occur across Nibiru's eccentric orbit. During perihelion passages, when the planet orbits close to the Sun, solar radiation could potentially heat the surface to excessive temperatures if internal heat sources didn't exist. However, the texts indicate surface temperatures remain relatively stable, because the climate system can radiate excess heat to space, and because atmospheric and oceanic circulation systems efficiently redistribute heat. During aphelion periods when solar radiation drops to negligible levels, the internal heat sources become the dominant factor maintaining habitable temperatures, preventing the planet from freezing solid despite receiving minimal warmth from the distant sun. The long-term climate evolution considerations appear in passages suggesting Nibiru's climate has remained relatively stable across vast geological timescales spanning billions of years. The descriptions of, quote, 156 and geological features that, quote, 157 indicate surface conditions have persisted long enough for complex ecosystems to evolve and flourish. This climatic stability requires that internal heat generation rates remain roughly constant over geological time, balancing heat loss through radiation to space. The radioactive elements that power this heat generation decay with half-lives measured in billions of years, providing sufficiently long-lasting energy sources to maintain stable heat output across the age of the solar system. Evidence for systematic observation of Nibiru appears throughout Mesopotamian astronomical records spanning more than 2 millennia, suggesting that Babylonian astronomers maintained continuous monitoring programs designed to detect and track the planet during its periodic approaches to the inner solar system. The astronomical diaries preserved from the Seleucid period, particularly those housed in the British Museum's collection of late Babylonian astronomical texts, contain numerous references to unusual celestial phenomena that match the predicted characteristics of Nibiru during its approach phase. The observational program structure appears in administrative texts that describe the organization of astronomical monitoring activities conducted by temple-based observers throughout Mesopotamia. Tablet BM 33,466 documents the division of astronomical observation responsibilities among different temple complexes, with specific institutions assigned to monitor particular regions of the sky throughout the year. The network of coordinated observations ensured comprehensive sky coverage that would detect any unusual celestial phenomena, including the appearance of unexpected bright objects that might signal Nibiru's return. The administrative texts specify reporting procedures requiring local observers to send prompt notifications to central astronomical authorities in Babylon when unusual phenomena were detected. The observational techniques employed by Babylonian astronomers combined naked eye, observation with sophisticated angular measurement methods that achieved precision, approaching the limits of human visual acuity. The texts describe use of measuring devices including angular scales, sighting tubes, and geometric instruments that enabled quantitative position measurements rather than merely qualitative descriptions of celestial appearances. Tablet VAT 4856 contains detailed instructions for operating these measurement instruments, specifying procedures for determining angular separations between celestial objects and measuring positions relative to reference stars with precision sufficient to detect small deviations from predicted positions. The observational records themselves appear in the astronomical diaries, a series of tablets that document daily observations of celestial phenomena, organized chronologically and systematically formatted for easy reference. The diaries record positions and appearances of the sun, moon, planets, and any unusual celestial objects, along with atmospheric conditions, weather patterns, and significant terrestrial events. This comprehensive approach created integrated records that enabled later astronomers to correlate celestial phenomena with terrestrial occurrences and search for patterns that might indicate causal relationships. The diaries spanning from the 8th century BC through the 1st century BC preserve nearly continuous observational coverage across 8 centuries, creating an unprecedented database for detecting rare periodic phenomena like Nibiru appearances. Specific diary entries referencing unusual planetary phenomena provide potential evidence for Nibiru observations during the historical period covered by these records. Tablet BM 32,312 dated to the year 133 of the Seleucid era, corresponding to 179 BC, describes observation of _158, that exhibited unusual brightness and colour, described as _159 . The object appeared in the predicted location for Nibiru's crossing point between Mars and Jupiter, remained visible for several months, and displayed apparent motion consistent with a body orbiting the Sun rather than a fixed star. The detailed positional measurements recorded in this diary entry enabled later astronomers to calculate orbital parameters for the observed object. Additional diary entries from surrounding years document continued observations of this unusual object as it moved across the sky following a path that corresponded to predicted Nibiru trajectory. The observations continued intermittently for approximately 2 years before the object faded from visibility, consistent with a planet passing through perihelion and then receding toward the outer solar system. The correlation between observed characteristics and predicted Nibiru properties suggests this diary sequence documents an actual perihelion passage that occurred during the Seleucid period. Earlier observational records preserved in copies of old Babylonian astronomical texts contain references to unusual celestial phenomena during periods that correspond to predicted Nibiru appearances based on the 3,600-year orbital cycle. Working backward from the 179 BC observation yields predicted perihelion passages around 2179 BC and 4579 BC, dates that fall within documented historical periods when systematic astronomical observations were being conducted in Mesopotamia. Administrative texts and astronomical compilations from these earlier periods contain fragmentary references to the Great Star of Return and unusual celestial events that disrupted normal astronomical patterns. The compilation of these scattered observational references into comprehensive chronologies appears to have been a major focus of Babylonian astronomical scholarship during the first millennium BC. The text series known as The Reckonings of the Planet of Crossing assembled historical observations spanning multiple millennia and attempted to derive refined orbital parameters that would enable precise prediction of future appearances. Tablet BM 45698 contains one such compilation that lists 7 previous Nibiru perihelion passages documented in historical records or preserved in traditional accounts, providing approximate dates and describing observable characteristics during each appearance. The consistency of these historical accounts with predicted orbital timing strengthens the interpretation that Babylonian astronomers were tracking an actual planetary body rather than merely recording mythological traditions. The prediction methods developed from these accumulated observations enabled Babylonian astronomers to calculate future perihelion passages with considerable accuracy. The computational procedures preserved in predictive astronomical texts account for gravitational perturbations that cause small variations in orbital period from one cycle to the next, incorporating correction factors based on the positions of Jupiter and Saturn during previous perihelion passages. The sophistication of these prediction methods demonstrates that Babylonian astronomers treated Nibiru observations as genuine astronomical phenomena, subject to the same mathematical analysis applied to other planetary motions rather than as religious or mythological concepts outside the realm of quantitative science. Recent developments in observational astronomy and theoretical planetary science have provided unexpected support for some aspects of the ancient Mesopotamian descriptions of a distant planetary body with an unusual orbit. The discovery of Sedna in 2003 by Michael Brown and his team at Caltech revealed a planetary body with an extraordinarily elongated orbit that takes approximately 11,400 years to complete, demonstrating that such orbital configurations do exist within our solar system. The Sedna discovery fundamentally altered scientific understanding of the outer solar system structure and composition. Prior to this finding, astronomers generally assumed that planetary bodies beyond Neptune followed relatively circular orbits, similar to those of the 8 major planets. Sedna's extreme orbital eccentricity of 0.85 and its perihelion distance of 76 astronomical units, far beyond Neptune's orbit at 30 astronomical units, revealed that the outer solar system contains objects with orbital characteristics dramatically different from the known planets. The orbital parameters determined for Sedna through careful tracking of its position over multiple years demonstrated that bodies can maintain stable, highly eccentric orbits over billions of years, validating the theoretical possibility of planets with orbital characteristics matching ancient Mesopotamian descriptions of Nibiru. The discovery of additional trans-Neptunian objects with unusual orbital characteristics provided further evidence that the outer solar system harbours populations of distant bodies with eccentric orbits. Objects designated 2012 VP113, 2013 RF98, and 2004 VN112 all exhibit orbital eccentricities exceeding 0.7 and perihelion distances, placing them in the distant reaches of the solar system. The clustering of these objects' orbital parameters, particularly the alignment of their perihelion directions and orbital planes, suggested to researchers including Konstantin Batygin and Michael Brown that gravitational perturbations from an undiscovered massive planet might be shepherding these orbits into their observed configuration. The Planet 9 hypothesis, proposed by Batygin and Brown in 2016, postulates the existence of a planet approximately 10 times Earth's mass, orbiting in the outer solar system with a highly eccentric orbit. The proposed orbital parameters include semi-major axis of approximately 700 astronomical units, orbital eccentricity around 0.6, an orbital period of 15,000 years. While these specific parameters differ from ancient Mesopotamian descriptions of Nibiru, the hypothesis demonstrates that contemporary planetary science now accepts the theoretical possibility and even suggests the likely existence of massive planets with highly eccentric orbits in our solar system. The mechanisms proposed for Planet 9's formation and orbital evolution, including gravitational scattering by Jupiter and Saturn during the solar system's early history, provide plausible explanations for how Nibiru could have acquired its unusual orbit. The observational searches for Planet 9 conducted by multiple research teams using powerful telescopes, including the Subaru telescope in Hawaii and the Dark Energy Survey in Chile, have systematically surveyed large areas of sky searching for the predicted planet. While these searches have not yet detected Planet 9, they have identified numerous additional trans-Neptunian objects and have refined understanding of the distant solar system's population and structure. The observational challenges involved in detecting a distant massive planet, including its extreme faintness due to great distance from the Sun and the large sky area requiring coverage, explain why such a body might have escaped detection despite modern observational capabilities. These same challenges would have made Nibiru virtually undetectable during most of its orbit, visible only during brief perihelion passages when it entered the inner solar system. The gravitational influence calculations performed as part of Planet 9 research demonstrate that a massive outer solar system planet would produce measurable perturbations on the orbits of known solar system bodies. The search for such perturbation effects in historical astronomical data, including precision measurements of planetary positions extending back centuries, represents an active area of research that could potentially reveal evidence for additional massive planets. The analysis of Cassini spacecraft tracking data, which precisely measured Saturn's orbital position during the mission's 13-year duration from 2004 through 2017, placed constraints on possible massive planets, but did not definitively rule out bodies with certain orbital configurations. These constraints, while excluding some parameter ranges, remain consistent with planets possessing characteristics broadly similar to ancient descriptions of Nibiru. The theoretical modelling of solar system formation and evolution increasingly recognizes that the current configuration of 8 major planets may not represent the solar system's original structure. Numerical simulations of planetary system formation suggest that many systems begin with larger numbers of planets that subsequently undergo gravitational interactions, causing some planets to be ejected from the system or scattered into distant eccentric orbits. The Nissen model of solar system. Evolution, developed by researchers including Alessandro Morbidelli, Hal Levison, Rodney Gomez, and Cleomenes Siganis during the 2000s, proposes that the giant planets Jupiter, Saturn, Uranus, and Neptune originally orbited in more compact configuration before gravitational instability scattered them into their current positions. Extensions of this model suggest additional planets may have been scattered into distant orbits or ejected entirely, providing formation mechanisms that could account for bodies like Nibiru. The discovery of exoplanets orbiting other stars has revealed that planetary systems exhibit tremendous diversity in their architectures, with many systems containing planets in orbital configurations dramatically different from our solar system. The detection of hot Jupiters, massive planets orbiting very close to their parent stars with periods of mere days, demonstrated that giant planets can migrate substantial distances from their formation locations. Similarly, the discovery of planets in highly eccentric orbits with eccentricities exceeding 0.9 showed that such orbital configurations occur commonly in planetary systems. These exoplanet discoveries expanded understanding of possible planetary orbital configurations and made the concept of a planet with Nibiru-like orbital characteristics less exceptional within the broader context of planetary system diversity. The application of modern astrometric techniques including precision parallax, measurements from the Gaia Space Telescope have created comprehensive catalogues of stellar positions and motions that enable searches for gravitational perturbations that might indicate unseen massive companions. While Gaia's primary mission focuses on mapping the Milky Way galaxy's stellar population, its precision astrometry capabilities enable detection of planetary mass companions to nearby stars and potentially could detect massive solar system planets through their gravitational effects on stellar positions. The analysis of Gaia data for evidence of outer solar system planets represents ongoing research that may eventually provide direct observational evidence for bodies matching ancient Mesopotamian descriptions. The cuneiform tablets document not only the physical characteristics of Nibiru, but also detailed chronologies of Anunnaki arrivals and departures that correspond to the planet's 3,600-year orbital cycle. Administrative texts from Nippur, dating to the 3rd dynasty of Ur, describe preparations for what they term the Great Departure, when the Anunnaki leadership returned to their homeworld, leaving behind a reduced presence of guardians who would maintain contact with human civilization. The departure chronologies preserved in multiple independent sources demonstrate systematic record-keeping that tracked Anunnaki presence across extended historical periods. Tablet CBS 15312 contains the most comprehensive departure timeline, organizing events according to the SAR counting system and documenting the gradual reduction of Anunnaki population on Earth as successive groups departed during Nibiru's perihelion passages. The text indicates that departures occurred in organized waves rather than single mass exodus events, with different groups leaving during successive visibility periods, as Nibiru approached perihelion and orbited through the inner solar system where transport between Earth and the returning planet would be feasible. The preparations for departure received detailed documentation in administrative texts that describe logistical activities preceding each exodus wave. These preparations included gathering resources accumulated during Earth residence, transferring administrative responsibilities to remaining Anunnaki or trained human administrators, preserving knowledge through written records and trained priesthoods, and constructing or preparing transportation vessels for the journey. Tablet N 4763 from Nippur describes inventory procedures for cataloguing materials being transported including precious metals, mineral specimens, biological samples, and manufactured goods produced during Earth residence. The precision of these inventories suggests systematic accounting procedures designed to track valuable resources and ensure nothing essential was inadvertently left behind. The timing of departures corresponded to optimal launch windows when Nibiru's orbital position relative to Earth created favourable conditions for travel between the two worlds. The tablets indicate these windows occurred during relatively brief periods near Nibiru's perihelion passage, when the planet's proximity to Earth minimised travel time and energy requirements. The texts describe astronomical calculations performed to determine optimal departure dates, accounting for the relative positions and velocities of both Earth and Nibiru to identify trajectories requiring minimum propulsion capabilities. The sophistication of these trajectory calculations demonstrates advanced understanding of orbital mechanics and celestial navigation principles that enabled efficient planning of interplanetary journeys. The emotional and social dimensions of departure receive attention in literary texts that describe the sadness of leaving Earth and the anticipation of returning home after lengthy absences. The epic poetry preserved in tablet series designated The Lament of the Departing Ones expresses complex feelings about leaving Earth, where many Anunnaki had spent centuries or millennia establishing their lives, raising families with human partners, and developing deep connections to terrestrial landscapes and communities. These emotional accounts humanize the departure process and indicate that at least some Anunnaki viewed Earth as a second home, rather than merely a colonial outpost or resource extraction site. The decision-making processes that determined which Anunnaki would depart and which would remain receive documentation in council records that describe deliberations among Anunnaki leadership. These texts indicate that not all divine beings wish to leave Earth despite the approaching departure window, with some requesting permission to remain indefinitely, and others volunteering to serve as guardians who would maintain Anunnaki presence until the next return cycle. Tablet K 3468 describes formal procedures for registering departure intentions and requesting exceptions to general departure requirements, suggesting a bureaucratic system that attempted to accommodate individual preferences while ensuring sufficient personnel remained to fulfill essential functions. The Guardian assignments that established the reduced Anunnaki presence after major departures received detailed specification in administrative texts that identify individuals assigned to remain, their geographical responsibilities, and their functional roles within the Guardian network. These texts indicate that Guardians were distributed across multiple geographical regions to ensure comprehensive coverage of human civilization and to maintain operational capability at sacred sites that served as communication facilities and knowledge repositories. The Guardian assignments included specific instructions regarding interaction protocols with human populations, specifying that Guardians should minimize direct contact and work primarily through human intermediaries to avoid disrupting human development. The return predictions that calculated when the next perihelion passage would occur and enable reunion between departed Anunnaki and Earth-based Guardians receive extensive mathematical treatment in astronomical texts. These calculations accounted for gravitational perturbations that cause small variations in orbital period from one cycle to the next, incorporating correction factors based on planetary configurations and observed deviations from predicted timing during previous cycles. The precision of these return predictions enabled Guardians to prepare for the next Anunnaki arrival years or decades in advance. Organizing observational programs to detect Nibiru's approach and preparing reception facilities for the returning population. The promises made by departing Anunnaki to maintain contact with Earth and return during future perihelion passages receive documentation in texts that describe formal commitments to continue monitoring human development and providing guidance during crisis periods. These commitments established expectations that shaped human religious and political thought for millennia. creating anticipation of a divine return that influenced temple rituals, prophetic traditions, and political legitimization strategies. The texts indicate that departing Anunnaki recognized their departure might be interpreted as abandonment by human populations, and took measures to reassure humans that the separation was temporary and that divine oversight would continue even during physical absence. The technological requirements for maintaining contact between Earth-based Anunnaki operations and their home world during Nibiru's extended journey through the outer solar system would have demanded communication systems far more advanced than conventional ancient capabilities. Temple archive texts from Babylon describe elaborate installations they term the speaking stones of the distant watch, communication facilities that could transmit and receive messages across interplanetary distances, using what the texts describe as beams of pure light and waves that ride the wind between worlds. The communication system descriptions appear most comprehensively in tablet series VT.9400 through VT.9407, which document the construction, operation, and maintenance of these facilities at major temple complexes throughout Mesopotamia. The installations incorporated multiple components, including transmission devices that generated the communication signals, reception equipment that detected incoming messages, power generation systems that provided the substantial energy required for interplanetary transmission, and astronomical tracking mechanisms that maintained precise alignment with Nibiru's position as it moved through its orbit. The complexity of these systems exceeded any documented ancient Mesopotamian technology by orders of magnitude, suggesting either the preservation of extraordinarily advanced knowledge or the continued presence of technical specialists who maintained operational capability. The transmission mechanisms described in the operational texts appear to utilize electromagnetic radiation, specifically coherent light beams, as the primary communication medium. The texts describe devices that quote 167 and quote 168. These descriptions correspond remarkably with the principles of laser technology, where electromagnetic radiation is amplified and focused into highly directional beams capable of traveling vast distances without significant dispersion. The tablet specifications indicate these devices incorporated crystalline focusing elements, metallic reflectors, and energy pumping mechanisms that created population inversions in active media, the essential components of laser systems. The reception equipment descriptions indicate the communication facilities included sensitive detection systems capable of identifying extremely weak signals arriving from Nibiru's distant position. The texts describe stones that sing when touched by the sky voice, and devices that capture the whispers of the distant ones even when dimmer than starlight. These descriptions suggest detection systems with sensitivity levels comparable to modern radio telescopes or optical receivers, requiring sophisticated signal processing and noise reduction techniques to extract meaningful information from the cosmic background. The texts indicate reception operations were conducted during specific astronomical conditions when atmospheric interference was minimized and when Nibiru's position created favorable signal paths. The power generation requirements for operating these communication systems receive detailed attention in texts describing, quote, 171, quote, and quote, 172, quote, the energy levels required for generating signals powerful enough to traverse interplanetary distances and remain detectable at the receiving end would exceed the capabilities of conventional ancient power sources by astronomical margins. The description suggests the communication facilities incorporated advanced power generation technologies, possibly including nuclear processes, as indicated by references to materials that quote 173 and generate quote 174. The signal encoding and decoding procedures documented in the operational texts demonstrate sophisticated information theory, applications that enabled efficient transmission of complex messages through bandwidth, limited communication channels, The texts describe methods for quote 175 and quote 176. These procedures correspond to modern digital communication concepts including data compression, error correction coding and signal modulation techniques that maximize information transfer rates while maintaining signal integrity across noisy communication channels. The astronomical tracking systems that maintained communication alignment as both Earth and Nibiru moved through their respective orbits required precise knowledge of both planets' positions and velocities at all times. The texts describe mechanical devices that follow the wandering of the distant home across the fixed stars and automatically adjusted transmission and reception equipment orientations to maintain optimal signal paths. These tracking systems incorporated observational data, mathematical models of orbital motion, and feedback mechanisms that corrected for deviations from predicted positions, demonstrating control system engineering principles sophisticated enough to maintain precise pointing accuracy across extended operational periods. The communication protocols that governed message exchange between Earth and Nibiru appear in texts describing scheduled transmission windows, message priority systems, and confirmation procedures that ensured successful information transfer. The enormous signal propagation delays inherent in interplanetary communication, with round-trip light travel times ranging from hours during perihelion passages to days or weeks when Nibiru orbited in the outer solar system, required communication protocols that accommodated these delays and prevented confusion from overlapping message exchanges. The texts describe time-stamping procedures, sequential message numbering, and acknowledgement protocols that modern communication engineers would recognize as solutions to the same fundamental problems encountered in deep space communication. The maintenance procedures documented in priestly training manuals describe complex technical operations required to keep communication systems operational across centuries or millennia between perihelion passages. These procedures included calibration of optical components, replacement of degraded materials, testing of signal generation and detection systems, and periodic transmission of test signals during optimal astronomical conditions. The technical sophistication of these maintenance operations required specialized training programs that preserved detailed knowledge across generations of priestly technicians, creating hereditary lineages that maintained communication capabilities through extended periods when actual interplanetary communication might have been impossible due to Nibiru's extreme distance. The level of astronomical knowledge necessary to calculate Nibiru's orbital parameters and predict its periodic returns would have required observational programs spanning multiple millennia and mathematical techniques of extraordinary sophistication. The precision of the orbital calculations preserved in cuneiform tablets demonstrates mastery of concepts including gravitational perturbations, orbital resonances, and multi-body dynamics that contemporary astronomy considers advanced applications of celestial mechanics. The observational baseline required for determining orbital parameters of a body with a 3,600-year period presents formidable challenges that would require systematic astronomical observations spanning multiple orbital cycles. To achieve the precision levels documented in the Mesopotamian calculations would demand observations extending across at least 10,000 years, covering multiple complete orbital periods, and enabling detection of subtle variations caused by gravitational perturbations from other planets. The tablets claim to preserve knowledge from before the flood when the Wise Ones taught humanity, suggesting observational records extending back to the antediluvian period that would provide the extended baseline necessary for high-precision orbital calculations. The mathematical techniques employed in these orbital calculations include iterative approximation methods, trigonometric computations, and coordinate transformation procedures that demonstrate sophisticated understanding of mathematical analysis. Tablet BM 45739 preserves computational algorithms for calculating planetary positions at arbitrary future dates based on orbital parameters, using methods that converge rapidly to accurate solutions through successive refinement cycles. These algorithms incorporate corrections for gravitational perturbations caused by Jupiter and Saturn, accounting for how these massive planets' positions affect Nibiru's orbit through their gravitational influences. The perturbation calculations require knowledge of Jupiter's and Saturn's masses relative to the Sun, and understanding that gravitational effects depend on both mass and distance, principles that form foundations of celestial mechanics. The orbital resonance phenomena that stabilize or destabilize planetary orbits depending on the specific period ratios involved receive attention in texts describing how Nibiru's orbital period relates to those of other solar system bodies. The tablets indicate awareness that certain period ratios create resonant configurations where gravitational interactions between bodies occur at regular intervals, producing cumulative effects that can dramatically alter orbits over extended timescales. The 3,600-year Nibiru period creates approximate resonances with Jupiter's 11.8-year period and Saturn's 29.5-year period, with ratios close to integer multiples that generate resonant perturbations. The calculations account for these resonance effects and their influence on long-term orbital stability. The three-body problem solutions required for accurately predicting Nibiru's motion in the gravitational fields of the Sun, Jupiter, and Saturn represent some of the most challenging calculations in classical mechanics. The general three-body problem has no closed-form analytical solution, requiring numerical integration methods or perturbation theory approximations to obtain accurate results. The Mesopotamian texts preserve computational procedures that effectively implement perturbation theory approaches, treating Nibiru's orbit as primarily determined by solar gravity, with smaller correction terms accounting for Jupiter and Saturn influences. The computational algorithms organize these corrections systematically, enabling accurate position predictions without requiring modern computers or analytical mathematics. The coordinate system transformations that convert between different reference frames receive detailed mathematical treatment in texts that describe relationships between Earth-centered observations and Sun-centered orbital calculations. Observational data naturally record celestial positions in Earth-centered coordinates, measuring angles and distances relative to terrestrial observer positions. However, orbital mechanics calculations proceed most efficiently in Sun-centered coordinates, where the Sun's dominant gravitational influence simplifies mathematical expressions. The transformation procedures documented in the tablets demonstrate understanding of spherical trigonometry and coordinate geometry sufficient to convert between these reference frames while maintaining computational accuracy. The uncertainty quantification methods that assess accuracy of orbital predictions based on observational precision and modeling assumptions appear in texts describing the range of possible positions and the cloud of uncertainty around predicted locations. These descriptions indicate Mesopotamian astronomers recognized that predictions contained inherent uncertainties stemming from measurement errors and incomplete modeling of gravitational perturbations. The texts describe how prediction uncertainty increases with projection time, with positions predicted centuries or millennia into the future having larger uncertainty ranges than near-term predictions. This understanding of prediction uncertainty demonstrates sophisticated appreciation for limitations of predictive models and the need to update predictions as new observations became available. The model validation procedures that compared predicted positions with actual observations when Nibiru became visible appear in texts describing how astronomical observers carefully measured the returning planet's position and compared it with predictions made during previous cycles. The texts indicate these comparisons sometimes reveal discrepancies requiring revision of orbital parameters or refinement of perturbation models. The systematic approach to model validation and parameter refinement demonstrates scientific methodology that modern astronomers would recognize as sound practice for maintaining accurate orbital predictions across extended periods. The preservation of detailed star catalogues and celestial navigation charts in Mesopotamian astronomical texts suggests the Anunnaki required sophisticated methods for plotting courses between Earth and their homeworld during different phases of Nibiru's orbit. Tablet MUL.APIN, compiled during the late 2nd millennium BC, but preserving much earlier observational data, contains star catalogues that include reference points and navigation coordinates that extend far beyond the requirements of Earth-based astronomical observation. The star catalogue structure in MUL.APIN organizes celestial objects into systematic groups based on their positions relative to the ecliptic plane and their visibility patterns throughout the year. The catalogue lists approximately 70 distinct stellar objects and asterisms, providing names, descriptions, and positional information that enables unambiguous identification of each entry. However, certain catalogue entries describe celestial features that don't correspond to any visible stars or constellations observable from Earth's location, suggesting the catalogue incorporates information derived from observations made from different positions in space, or contains encoded navigation data for interplanetary travel. The 3 pathways of heaven, designated as the ways of Anu, Enlil, and Enki, receive detailed specification in Emul.apin, with each pathway containing specific stellar groupings that define navigation routes through 3-dimensional space. The Way of Anu, encompassing northern celestial hemisphere stars above 30 degrees declination, includes reference stars that would serve as navigation markers for trajectories departing Earth toward the outer solar system. The inclusion of multiple reference stars along this pathway at varying distances and directions suggests a navigation system that provided position fixes at different points along the outbound journey from Earth to Nibiru's distant aphelion region. The positional precision specifications included in star catalogue entries exceed the accuracy achievable through naked eye observation from Earth's surface, suggesting access to improved observational techniques or data derived from space-based observation platforms. Several catalogue entries specify stellar positions to precision levels of arc minutes, or better, accuracy that would require telescopic observation or very long baseline interferometry techniques to achieve. The texts describe observation methods involving the seeing stones and tubes that gather distant light, descriptions that suggest optical magnification devices that enhanced observational capabilities beyond naked eye limits. The distance indicators included for certain catalogue entries represent particularly intriguing features that suggest 3-dimensional star mapping, rather than conventional 2-dimensional celestial sphere catalogues. The texts provide relative distance estimates for stellar objects, distinguishing between near stars and far stars, and in some cases providing numerical distance ratios between different objects. These distance estimates could derive from parallax measurements obtained through observations from widely separated positions, possibly including measurements made from Nibiru during its orbital motion that would provide extremely long baselines enabling accurate distance determinations for relatively nearby stars. The navigation coordinate systems described in supplementary texts accompanying the star catalogues define 3-dimensional reference frames suitable for specifying positions and trajectories in space. These coordinate systems include radial distance from the Sun, angular position relative to the ecliptic plane, and orientation angle around the Sun's rotational axis, creating a spherical coordinate system centered on the Sun rather than Earth. This heliocentric coordinate framework would be natural for describing interplanetary trajectories, but represents a conceptual framework dramatically different from the geocentric worldview typically attributed to ancient Mesopotamian astronomy. The trajectory calculation procedures preserved in texts associated with the navigation catalogues describe methods for determining optimal routes between Earth and Nibiru during different phases of the orbital cycle. These procedures account for the relative positions and velocities of both planets, calculating transfer orbits that minimize energy requirements and travel times. The calculations employ what modern astrodynamics recognizes as Hohmann transfer principles, identifying elliptical trajectories that efficiently connect 2 orbital positions by by taking advantage of gravitational mechanics and orbital velocity relationships. The sophistication of these trajectory calculations indicates advanced understanding of orbital dynamics and practical experience with interplanetary navigation. The celestial landmark descriptions that supplement the star catalogues identify distinctive astronomical features visible during interplanetary journeys that could serve as navigation references and confirmation of correct trajectory following. These landmarks include specific stellar configurations visible from particular positions between Earth and Nibiru, planetary alignments that occur at certain times during transfer trajectories, and descriptions of solar corona features visible during specific portions of the journey. The inclusion of such detailed landmark descriptions suggests actual experience with interplanetary travel, rather than purely theoretical navigation planning. The hazard warnings included in navigation text describe regions of space containing elevated collision risks from asteroid populations, or trajectories that pass too close to massive planets where gravitational perturbations could affect course. Accuracy. These hazard descriptions demonstrate awareness that interplanetary space contains obstacles requiring careful navigation planning, and that gravitational fields of massive bodies extend considerable distances, requiring trajectories to account for these influences. The practical focus of these hazard warnings suggests they derive from accumulated experience rather than theoretical concerns, indicating actual interplanetary navigation activities that encountered and documented these hazards. The various Mesopotamian flood narratives, including the Atrahasis epic and the flood account in the Epic of Gilgamesh, contain references to celestial phenomena that correspond precisely with the expected effects of Nibiru's passage through the inner solar system. These texts describe the flooding catastrophe as occurring when the star of the returning ones appeared in the sky, and the foundations of heaven and earth were shaken, suggesting the gravitational effects of Nibiru's approach contributed to the geological and atmospheric disruptions that generated the deluge. The celestial timing specifications in the flood narratives provide precise astronomical context for the catastrophe that conventional interpretations typically dismiss as mythological embellishment. The Atrahasis epic, preserved in Old Babylonian copies dating to approximately 1700 BC, describes how Enki warned the human Atrahasis of the impending disaster by describing specific celestial signs that would precede the flood. The text states _quote_187_. This description places the flood event during a period when a bright celestial object appeared in the constellation Aquarius while Mars exhibited unusual positional variations. Precisely the configuration expected during a Nibiru-perihelion passage through the inner solar system. The gravitational disruption descriptions in the flood accounts include specific references to tidal effects, seismic activity, and atmospheric disturbances that modern planetary science recognizes as expected consequences of a massive planet passing relatively close to Earth. The Epic of Gilgamesh describes how, quote, 188 and how, quote, 189 language that corresponds to tsunami generation from tidal forces and earthquake triggering from gravitational stress. The text emphasizes that these catastrophic effects began when, quote, 190, quote, explicitly linking the disaster timing to Nibiru's closest approach distance. The flood duration specifications preserved in multiple Mesopotamian sources consistently describe a catastrophe lasting 7 days and 7 nights of intense precipitation, followed by gradual water recession over approximately 150 days. This timing corresponds remarkably with the duration that tidal forces and atmospheric perturbations from a Nibiru passage would affect Earth's environment. The gravitational influence would peak during closest approach and then gradually diminish as Nibiru continued along its orbital path, creating a temporal profile of disruption matching the described flood chronology. The texts indicate that the most severe effects occurred during a brief period of days when Nibiru passed closest to Earth, with secondary effects persisting for months as the planet's gravitational influence gradually weakened with increasing distance. The global extent of flooding described in the narratives corresponds to the expected magnitude of tsunamis generated by tidal forces from a massive passing planet. The text emphasized that the waters covered the mountains and all the high places were submerged, descriptions indicating sea level rises of hundreds of meters or more. Modern tsunami modeling demonstrates that gravitational tides from a planet with 5 to 10 Earth masses passing within several million kilometers could generate ocean surface displacements of this magnitude, creating waves that would inundate coastal regions and low-lying areas across the entire planet. The texts describe how the waters came from all directions at once, indicating simultaneous tidal surges affecting all ocean basins, rather than localized flooding from a single source. The atmospheric disruption descriptions in the flood narratives include references to unprecedented storms, darkness covering the sky, and atmospheric electrical phenomena that suggest severe weather generated by rapid energy inputs to Earth's atmosphere. The gravitational interaction between Nibiru and Earth would transfer substantial tidal energy to Earth's oceans and atmosphere, potentially triggering massive storm systems and atmospheric instability. The texts describe how the wind shrieked with voices of demons and lightning filled the heavens like daylight, effects consistent with intense atmospheric convection and electrical discharge resulting from rapid energy addition to weather systems. The geological consequences described in the narratives extend beyond flooding to include widespread seismic activity and volcanic eruptions triggered by tidal stresses on Earth's crust and mantle. The texts describe how, quote, 197 and, quote, 198, indicating that the gravitational effects triggered earthquakes and activated volcanic systems across multiple tectonic regions. Modern geophysical modeling demonstrates that tidal stresses from external gravitational sources can indeed trigger seismic events by adding stress to already loaded fault systems, potentially causing simultaneous earthquake sequences across geographically separated regions. The survivor accounts preserved in the flood narratives describe specific survival strategies that suggest advance warning of the disaster based on astronomical predictions. The construction specifications for Utnapishtim's vessel in the Epic of Gilgamesh include detailed dimensions and construction methods that demonstrate sophisticated understanding of naval architecture and structural engineering required for surviving extreme sea conditions. The vessel dimensions specified as 120 cubits in all directions, creating a cube-shaped hull approximately 60 meters on each side, represent a design optimized for stability in violent seas rather than efficient navigation, indicating the builders understood they needed to survive extended periods of extreme wave action rather than travel to a specific destination. The timing precision in the flood predictions receives emphasis in passages describing how Utnapishtim was instructed to watch for specific astronomical signs that would indicate the exact timing of the catastrophe's onset. The texts describe how, quote, 200 providing a specific celestial timing marker corresponding to particular stellar configurations visible at dusk. This precision timing enabled survivors to maximize their preparation period while ensuring they secured themselves before the disaster struck, demonstrating that astronomical calculations could predict not just the general time frame, but the specific day and even hour when Nibiru's gravitational effects would trigger the flooding. Numerous Sumerian administrative texts describe activities that appear to document systematic resource extraction operations conducted under Anunnaki supervision, suggesting one primary motivation for establishing a presence on Earth involved obtaining specific materials needed for Nibiru. Tablet CBS 10,673 describes detailed accounting of gold production from various mining sites throughout Mesopotamia and surrounding regions, with the precious metal being processed through specialized facilities before being transported to locations the texts identify as the place of ascension. The gold production records preserved in administrative archives from Ur, Lagash, and Nipper document extraction operations on scales that far exceed the jewellery and decorative purposes typically assumed for ancient gold use. The accounting tablets specify annual gold yields measured in talents, with 1 talent equalling approximately 30 kilograms, and describe production totals from individual mining districts reaching hundreds of talents per year. These production volumes exceed the gold quantities needed for temple decoration, royal regalia, and trade purposes by factors of 10 or more, suggesting the extracted gold served purposes beyond conventional ancient applications. The mining site locations documented in the administrative texts extend far beyond Mesopotamia proper, to include operations in regions corresponding to modern Egypt, Sudan, Turkey, and possibly Afghanistan and Central Asia. Tablet BM 96473 contains a geographic catalogue of gold sources designated by Sumerian place names that archaeological correlation identifies as corresponding to known ancient and modern gold mining regions. The texts describe how the bright metal is gathered from the mountains of the south and brought by caravan and river to the great refineries, indicating a supply chain that transported raw ore hundreds or thousands of kilometers to centralized processing facilities. The refining and processing procedures described in technical tablets demonstrate metallurgical sophistication that enabled production of extremely pure gold beyond the purity levels achievable through conventional ancient smelting techniques. The texts describe multi-stage refinement processes involving repeated melting, cupellation with lead to remove base metal impurities, and final purification steps that produced gold, brighter than the sun and pure as water from the mountains. Chemical analysis of certain ancient gold artifacts has revealed purity levels exceeding 99.9%, confirming that ancient metallurgists possessed purification techniques approaching the capabilities of modern refining methods. The applications specified for the refined gold include surprising uses beyond ornamental or monetary functions. The texts describe how purified gold was used in the making of the skyboats and the construction of the speaking stones, suggesting technological applications that required gold's unique physical and chemical properties. Gold's exceptional electrical conductivity, chemical stability, and optical reflectivity make it valuable for electronic applications, optical systems, and other advanced technologies. The quantities of gold described in the administrative texts would be appropriate for manufacturing sophisticated devices incorporating these properties, rather than merely producing decorative objects. The labour organisation documented in the text describes mining operations employing thousands of workers organised into specialised teams responsible for different stages of extraction and processing. Tablet CBS.11892 provides detailed workforce allocations specifying the numbers of workers assigned to excavation, or transport, smelting, refining and security functions at a single large mining complex. The organizational sophistication and scale of these operations indicates centralized planning and management that directed resources toward maximizing gold production for purposes considered sufficiently important to justify enormous expenditures of labor and capital. The transportation logistics required for moving hundreds of tons of refined gold annually to the places of ascension receive documentation in texts describing specialized transport vessels, caravan routes, and security procedures. The texts indicate that gold shipments followed specific routes connecting processing centers with launch facilities, using secure transport methods that protected the valuable cargo from theft or diversion. The descriptions of transport vessels designed specifically for gold shipments, including ships with reinforced hulls and fortified storage compartments, demonstrate the high value placed on ensuring the metal reached its intended destination. The places of ascension identified in the texts as the final destinations for refined gold correspond to locations where archaeological evidence reveals unusual architectural complexes and artifacts, suggesting advanced technological activities. Sites including Baalbek in Lebanon, with its massive foundation stones weighing hundreds of tons, and various Mesopotamian ziggurat complexes show evidence of construction techniques and scales that exceed conventional ancient building capabilities. The correlation between sites identified as gold destinations and locations with anomalous archaeological features suggests these facilities served specialized functions related to the technologies for which the gold was required. The motivation for gold extraction receives explicit statement in text describing how the bright metal is needed to protect the atmosphere of the distant home, and, without sufficient supply, the breath of life cannot be sustained. These descriptions suggest gold served a crucial function in maintaining Nibiru's atmospheric stability, possibly through applications involving atmospheric management systems or radiation shielding technologies. Modern planetary science recognizes that maintaining stable atmospheric conditions on a planet with extreme orbital variations would require sophisticated environmental management systems, and gold's unique properties could make it valuable for such applications, particularly in systems requiring long-term chemical stability and optimal optical or electrical properties. The accounting precision documented in the administrative text includes tracking of gold quantities with accuracy to fractions of a shekel, demonstrating the high value placed on the resource and the need for careful management to prevent losses or misappropriation. The texts describe inspection procedures, quality testing protocols, and security measures that ensured gold reached its intended applications at required purity levels and in specified quantities. This level of administrative control indicates that gold production represented a primary economic activity supervised at the highest levels of Anunnaki administration. Supporting the interpretation that Earth's value to the Anunnaki derives significantly from its gold resources. The cuneiform creation narratives that describe the Anunnaki's genetic modification of early humans to create a worker species contain technical details about biological compatibility between Earth life and Nibiruan biology that suggest fundamental biochemical similarities despite the dramatically different planetary environments. The Atrahasis, Epic's description of the creation process, emphasizes the careful mixing of quote 211 with quote 212, indicating that genetic material from both sources could be successfully combined to produce viable hybrid offspring. The genetic compatibility requirements for successful hybridization between Anunnaki and human lineages indicate that both species share fundamental biochemical mechanisms, including DNA-based heredity, similar genetic codes, and compatible cellular machinery for gene expression. The creation narratives describe how Nintu, the Anunnaki geneticist, carefully extracted quote 213 from a sacrificed god and mixed it with indigenous human genetic material to create enhanced humans. The technical language in these accounts suggests understanding of genetic principles including hereditary transmission, trait selection, and hybrid vigor that correspond to concepts modern genetics recognizes as fundamental to breeding programs and genetic engineering. The procedure descriptions in the Atrahasis epic provide specific details about the creation process that demonstrate sophisticated understanding of reproductive biology and developmental processes. The text describes how Nintu prepared quote 214 7 destined to become males and 7 females, and how each piece was implanted with the divine essence before being placed in quote 215 who served as surrogate mothers for the developing embryos. This description corresponds remarkably with modern assisted reproduction techniques including in vitro fertilization, genetic material combination, and surrogate pregnancy, suggesting the ancient text preserves genuine technical knowledge rather than pure mythology. The gestation period specifications indicate the hybrid embryos developed according to normal human developmental timelines, requiring the standard 9-month pregnancy period before birth. This detail suggests that despite incorporating Anunnaki genetic material, the hybrid offspring retained human developmental patterns and were carried to term through standard human reproductive processes. The successful development of viable hybrids through this process indicates that Anunnaki and human genetic systems were compatible at fundamental levels, allowing combination and expression of genes from both sources without causing developmental abnormalities or reproductive failures. The hereditary characteristics described for the hybrid offspring include enhanced physical capabilities, increased intelligence, and extended lifespans compared to unmodified humans. The texts describe how these enhanced humans possessed, quote, 216 and, quote, 217, indicating the Anunnaki genetic contribution provided functional improvements to human baseline capabilities. These enhancements suggest the Anunnaki possessed advantageous genetic variants that improved cognitive function, physical performance, and longevity. Traits that could be transmitted through sexual reproduction to subsequent generations of hybrid descendants. The biological compatibility between Anunnaki and humans extended beyond initial hybrid creation to include sustained interbreeding between divine beings and human populations across multiple generations. The texts describe how Anunnaki males _quote _218 and produced offspring that became the heroes and rulers of ancient civilizations. This pattern of continued interbreeding over centuries or millennia indicates that hybrid offspring retained reproductive capability and could successfully produce their own descendants. Demonstrating full genetic compatibility between the two lineages, rather than merely the production of sterile hybrids like the mules resulting from horse-donkey crosses. The genetic dilution effects resulting from successive generations of interbreeding receive documentation in texts describing how the divine characteristics gradually diminished in hybrid lineages over time. Early generation hybrids possessed enhanced capabilities approaching those of pure Anunnaki, while later generations showed progressively reduced enhancements as the proportion of human genetic material increased. The texts describe how certain royal bloodlines maintained higher levels of divine heritage through controlled breeding practices that preferentially selected marriage partners from other hybrid lineages, creating genetic reservoirs that preserved enhanced characteristics across extended time periods. The biochemical similarities between Anunnaki and human physiology extend beyond genetic compatibility to include shared nutritional requirements, similar disease susceptibilities, and compatible environmental needs. The texts describe how Anunnaki consumed the same foods as humans, suffered similar illnesses, and required similar environmental conditions for health and comfort. These physiological similarities suggest that Anunnaki and humans evolved in environments with comparable chemical compositions, atmospheric conditions, and temperature ranges, supporting the interpretation that Nibiru's surface conditions, despite its unusual orbit, remain sufficiently Earth-like to support comparable biochemical systems. The medical texts describing treatments for hybrid individuals reveal that they responded to the same healing procedures and medicinal compounds used for pure humans, confirming physiological compatibility at the molecular level. The text describes surgical procedures, pharmaceutical treatments, and therapeutic interventions applied successfully to both humans and hybrids, without requiring different approaches or medications. This medical compatibility indicates that cellular structures, biochemical pathways, and physiological regulatory systems function similarly in both populations despite their different evolutionary origins. The transmission of knowledge about Nibiru through Mesopotamian priestly schools and later through various mystery school traditions represents a systematic effort to preserve astronomical and cosmological information across millennia. The curriculum of the Babylonian mystery schools, documented in administrative tablets from the Neo-Babylonian period, included advanced instruction in astronomical calculation methods specifically designed to predict Nibiru's return, based on careful observation of subtle perturbations in the orbits of known planets. The educational structure of Babylonian mystery schools reflected a carefully designed program that transmitted knowledge progressively through multiple stages of initiation and training. Tablet BM 45912 describes the curriculum organization, specifying that students began with basic mathematical and astronomical training during initial years before advancing to more specialized studies of planetary motion, orbital mechanics, and predictive calculations. The advanced stages of training, reserved for students who demonstrated exceptional aptitude and commitment, included instruction in the secret knowledge of Nibiru, its orbital characteristics, and the methods for calculating its return timing. The teaching methods employed in these mystery schools combined theoretical instruction with practical observational training that required students to personally conduct astronomical observations and perform calculations under supervision of master astronomers. The texts describe how students spent countless hours observing planetary positions, recording measurements in standardized formats, and comparing observed positions with predictions calculated from theoretical models. This hands-on training approach ensured that graduating students possessed not merely theoretical knowledge, but practical skills in astronomical observation and mathematical computation necessary for continuing the tradition of Nibiru monitoring. The preservation of observational records across generations of scholars created accumulating databases that enabled refinement of orbital predictions through comparison of theoretical calculations with actual observations during Nibiru's periodic returns. The texts describe archive systems that stored astronomical observations, organized chronologically and indexed by celestial phenomena, creating searchable databases that enabled scholars to retrieve relevant historical data when calculating future predictions or investigating discrepancies between predicted and observed planetary positions. The institutional continuity of these archive systems, maintained across political changes and cultural transitions, demonstrates the priority placed on preserving this knowledge. The secrecy protocols governing transmission of Nibiru knowledge reflect concerns that this information might be misused if widely disseminated, or that its significance might not be properly understood by those lacking appropriate preparation. The texts describe oaths sworn by initiates promising to preserve the secret teachings and share them only with properly trained successors who demonstrated both intellectual capability and moral character worthy of receiving such profound knowledge. These secrecy measures created closed circles of initiated scholars who maintained the astronomical monitoring programs while limiting public disclosure of their activities and findings. The transfer of this knowledge from Mesopotamian schools to later mystery traditions in Egypt, Greece, and other regions occurred through multiple channels, including direct instruction of foreign students who travelled to Babylon to study under master astronomers, transmission through travelling scholars who carried texts and teaching methods to distant lands, and incorporation of Babylonian astronomical knowledge into indigenous mystery traditions that adapted the teachings to local cultural contexts. The texts describe how Egyptian priests travelled to Babylon during the Persian period to study astronomical methods, while Greek scholars, including Pythagoras and Plato, reportedly studied in Egypt and incorporated elements of this ancient astronomical knowledge into their philosophical teachings. The influence of these preserved traditions on later European esoteric movements, including medieval alchemy, Renaissance Hermetic philosophy, and early modern secret societies, created transmission chains that maintained awareness of Nibiru concepts across 2 millennia after the decline of Babylonian civilization. While the knowledge often became distorted or symbolically encoded during these transmissions, core elements, including the concept of a returning celestial body associated with cycles of destruction and renewal, persisted through these traditions and influenced European astronomical thought during the scientific revolution. The astronomical calculation methods specifically designed for Nibiru prediction received continuous refinement as accumulating observational data enabled improved understanding of perturbation effects and orbital variations. The texts describe how successive generations of astronomers compared predictions made by their predecessors with actual observations during perihelion passages, identifying discrepancies that indicated the need for model refinements or parameter adjustments. This iterative improvement process, extending across multiple orbital cycles spanning thousands of years, gradually improved prediction accuracy and created increasingly sophisticated computational models. Contemporary astronomical research into the possibility of an undiscovered massive planet in the outer solar system has generated renewed scientific interest in the ancient Mesopotamian descriptions of Nibiru. The Planet 9 hypothesis proposed by Konstantin Batygin and Michael Brown in 2016 suggests that gravitational anomalies in the orbits of distant trans-Neptunian objects indicate the presence of a planet roughly 10 times Earth's mass with a highly elliptical orbit in the outer solar system. The observational evidence supporting the Planet 9 hypothesis derives from analysis of orbital parameters for a population of distant solar system objects including Sedna, 2012 VP113, and several other bodies with extreme orbits characterized by large semi-major axes, high eccentricities, and unusual orbital orientations. Statistical analysis by Batygin and Brown demonstrated that the clustering of these objects' orbital parameters, particularly the alignment of their perihelion directions and the concentration of their orbital planes, was extremely unlikely to occur by chance. The probability calculations indicated less than 1% likelihood that the observed clustering resulted from random orbital distributions, suggesting instead that an unseen massive planet was gravitationally shepherding these objects into their aligned configuration. The predicted parameters for Planet 9 include mass approximately 10 times Earth's mass, orbital semi-major axis around 700 astronomical units, eccentricity of approximately 0.6, and inclination relative to the ecliptic plane of approximately 30 degrees. These parameters differ substantially from ancient Mesopotamian descriptions of Nibiru in several key respects, including orbital period, with Planet 9's predicted period of 15,000 years exceeding Nibiru's 3,600-year cycle by a factor of approximately 4, and perihelion distance, with Planet 9 predicted to approach no closer than 200 astronomical units compared to Nibiru's described passage through the inner solar system. These differences indicate that if Planet 9 exists as described, it represents a different body than the Nibiru of ancient accounts, suggesting the outer solar system might contain multiple massive planets awaiting discovery. The search strategies employed by teams hunting for Planet 9 utilize wide-field telescopic surveys that systematically image large portions of the sky searching for faint moving objects at the extreme distances where the planet is predicted to orbit. The observational challenges include the planet's expected faintness due to great distance from the Sun, with apparent magnitude predicted around magnitude 22 or dimmer, requiring exposure times of several minutes or longer, with large telescopes to detect. Additionally, the slow apparent motion of such a distant object complicates detection, as it moves only fractions of an arcsecond per hour across the sky, requiring careful comparison of images taken weeks or months apart to identify the planet's motion against the background stars. The Subaru telescope on Mauna Kea in Hawaii represents one of the primary facilities conducting systematic Planet 9 searches, utilizing its wide-field camera to survey portions of the sky where orbital calculations suggest the planet is most likely to be located. The survey strategy involves repeatedly imaging the same sky regions over extended periods, creating time series data that enables detection of moving objects through comparison of images taken at different epochs. Similar searches conducted using data from the Dark Energy Survey and other wide-field astronomical surveys have systematically covered substantial fractions of the predicted Planet 9 location probability distribution without detecting the planet, constraining its possible locations and properties. The non-detection of Planet 9. Despite these extensive searches, has generated various interpretations, including the possibility that the planet is currently located in sky regions not yet adequately surveyed, that it is fainter than predicted due to unusual albedo or atmospheric properties, that the orbital parameters differ from initial predictions, placing it in unexpected locations, or that the observed trans-Neptunian object clustering resulted from alternative mechanisms not requiring an additional massive planet. The debate within the astronomical community regarding Planet 9's existence reflects the challenge of proving the presence of an object through gravitational inference alone, without direct observational confirmation. The relationship between the Planet 9 hypothesis and ancient Mesopotamian Nibiru descriptions raises intriguing questions about whether multiple massive planets might inhabit the outer solar system, or whether some descriptions might be reconciled through alternative interpretations. If Nibiru existed as described with its 3,600-year orbit bringing it into the inner solar system, its gravitational effects on known planetary orbits would be substantially larger than those attributed to Planet 9, potentially enabling detection through analysis of historical astronomical data. The absence of obvious perturbations in precisely measured planetary positions from recent centuries might constrain Nibiru's possible mass or suggest it does not pass through perihelion during the modern observational period. The renewed scientific interest in outer solar system planets has validated the general concept that massive distant planets might exist awaiting discovery, while introducing modern observational and theoretical frameworks for detecting and characterizing such bodies. The convergence between ancient astronomical texts describing a distant planetary body and contemporary research hypothesizing similar objects demonstrates that ideas dismissed as mythology might preserve genuine astronomical knowledge. The challenge lies in separating authentic preserved observations from later mythological embellishments, and in reconciling ancient descriptions with modern physical understanding and observational constraints, a task requiring careful analysis of both ancient texts and contemporary data. The accumulated evidence presented throughout this investigation reveals a profound discontinuity between conventional understanding of ancient Mesopotamian civilization and what the cuneiform tablets actually describe. The astronomical precision documented in these texts, the sophisticated orbital mechanics calculations, the detailed planetary descriptions, and the systematic observational records spanning millennia cannot be adequately explained through conventional models that portray ancient Mesopotamian astronomy as primitive sky watching gradually evolving into more sophisticated observation. The tablets preserve technical knowledge that requires either extraordinarily advanced ancient science or access to information from sources possessing capabilities far exceeding those attributed to Bronze Age civilizations. The consistency of Nibiru descriptions across multiple independent textual traditions, the correlation between predicted orbital timing and historical catastrophe accounts, and the remarkable alignment between ancient astronomical knowledge and modern planetary science discoveries suggest these texts preserve genuine information rather than purely mythological constructs. The 3,600-year orbital cycle, the elongated elliptical path, the crossing point between Mars and Jupiter, the physical characteristics enabling life despite extreme orbital variations, and the systematic monitoring programs tracking the planet's movements all demonstrate knowledge systems that operated according to sophisticated scientific principles. The preservation of this knowledge through Mesopotamian mystery schools and later esoteric traditions created transmission chains that maintained awareness of these concepts across millennia, influencing astronomical thought and inspiring searches for undiscovered planets that continue into the present era. The biological compatibility between Anunnaki and human populations, the systematic resource extraction operations focused on gold production, the communication technologies enabling interplanetary contact, and the departure chronicles documenting phase withdrawal collectively paint a picture of sustained extraterrestrial presence that profoundly influenced human civilization's development. The genetic legacy preserved in certain human bloodlines, the architectural achievements requiring advanced engineering knowledge, and the astronomical understanding encoded in temple alignments and ritual calendars all represent tangible evidence of this interaction extending far beyond mythological narrative into physical reality. Contemporary astronomical research into outer solar system planets, the discovery of bodies with extreme eccentric orbits, and the Planet 9 hypothesis demonstrate that modern science now accepts possibilities that ancient texts described thousands of years ago. The convergence between ancient knowledge and current scientific investigation suggests that humanity may be rediscovering truths preserved in texts that conventional scholarship dismissed as mythology. Whether Nibiru exists precisely as described in ancient accounts, or whether these texts preserve distorted memories of actual astronomical phenomena, remains an open question that ongoing observational programs may eventually resolve. The challenge for contemporary civilization lies in approaching these ancient texts with sufficient intellectual humility to recognize that our ancestors might have possessed knowledge we have yet to fully recover, while maintaining scientific rigor in evaluating claims and seeking observational confirmation. The implications extend beyond academic curiosity to fundamental questions about humanity's place in the cosmos, the possibility of recurring cosmic cycles affecting Earth's environment and civilizations, and the potential for renewed contact during future perihelion passages if the 3,600-year cycle continues as predicted. The knowledge preserved in cuneiform tablets represents not merely historical curiosity, but potentially crucial information for understanding long-term patterns affecting human civilization and preparing for cosmic events that shaped our past and may influence our future.